I don't need empty promises.
Are not empty promises.
So this is what's on our to-do list
What?
after March 4th.
Okay.
Going to Chicago?
We are.
Yes. We are going to Canada.
We are.
We are. We are going to the Pixar thing.
Well, that I knew about. That one I knew.
Yeah, then we got to book off like the Delta one. That's all I got for that. I don't know. I was on this thing. It was like Chicago downtown. And I saw all these cool things we do. And then I would have faced my fear and do the little tilt thing.
Tilt thing.
In Chicago, where you can overlook the city.
Oh, the little sky thing that you can view.
Yeah, I was thinking about could I do it, and it didn't go well inside my head, but I said I'm gonna do it anyway. Because then I was like, well, maybe, I feel better if I could just like you was there with me. But I was like, no, it's probably a weight limit. It's only for one person per window, unless you're a child. And I said, well, all fails. I may just have a panic attack. At least I tried it.
I see. I see. I know.
And he said I need a fucking intro.
I gotta do an intro.
You always do. My name's Omasu, and today, me and another person that's also in the room with me, we're gonna go over a test together.
Well, seems like you just introed it, so I don't gotta do it now. But yeah, so what we're gonna do today is we're gonna go through a test, and we're gonna make sure our logic is correct, and we're gonna bring even though the score is a little inflated, so it's useful. We took the AMC sample. We're gonna go through and grab all the knowledge that we can. Give me 1 second.
Is all the AMC tests inflated or just a sample?
The what?
All the AMC tests?
Just a sample. Now granted, upon looking around, it depends upon, because it's hard to say, because some people are like, it's inflated. Some people are like, no, it's accurate. So who really knows? It just depends upon when you actually take the test. It just depends upon how hard the test is. Some people said it was like really accurate to how the test was. Some people said it wasn't. So bottom line is nobody actually knows. People are just talking.
Well, I think it depends on what test you take and how much you actually prepared.
Well, yeah, I think that it's still useful. It still gives you a ballpark of what you'll probably get, right? Now, you just got to keep doing it in terms of like,
right.
Keep studying. But yeah, hold on. Sorry.
You literally said you're okay.
All right. So pull this up, and that. All right, we are ready to start for real this time. So do you want to do like study for a period of time and then take a break?
We'll see.
That's it.
No. What are you at?
That's the only option. All right, so I'll put the timer on we'll put it on for 2 hours, I guess. Is that okay with you?
Do I have a choice?
I mean, yes, that's why I'm asking.
No, it's fine.
Don't use your government. We on the internet. Letting people know your government.
Your first name?
Yeah, that's part of my government.
Okay.
All right. So let's go for it though. Just say Masu. You can go into the other room if you want to. All right. We'll start now though, for real. Are you ready?
I'm ready.
3, 2, 1, go. Okay. So, all right. So this question is asking about compound 1 is used to treat HIV infection based on its ability to act as.
So, we're gonna start with computer. Completely wrong. So, thinking about the question itself, it's saying that it's basically a drug to treat HIV. So, what you want a drug to do is basically counteract the symptoms or whatever the case may be, right? So, we're gonna be looking for something that's going to counteract the infection, the bacteria, or whatever the case may be, right?
Yeah.
Catalyst. What is a catalyst? Catalyst speeds up a reaction, doesn't even get used up to begin with, can't be a catalyst, right?
Right.
Placebo. Placebo are legit just what? Okay?
Oh, sugar. Yeah.
Does absolutely nothing. And then it briefly boils it down to an agonist and an antagonist. The agonist enhances or duplicates the
Or turn something on.
right versus antagonist turns something off and pivots it. So like we had said before, we're looking for something that's going to work against it, so that would be the antagonist.
Correct. That's what I got, at least, and they said it's right. But yeah,
You already read the Jack one.
the Jack one. Oh, you talking about Jack Weston again?
All right.
Yeah, let's actually pull that up.
All right.
Jack Weston.
All right. You can pull it up.
Oh, this is like the website for all of them.
Yes.
Sample test, chemistry, physics sample test. Okay, I got it up.
All right. So it says number one, their reasoning was the passage says compound 1 is a transition state analog for the HIV protease enzyme, which means it mimics the product of substrate binding. Did you know that? However, it produces enzymes for the formase function, which we know because we use treat HIV. Not amplify the effect, but activations are not inhibited. And then antagonists will inactivate the enzyme, which is noted just above. Seems to be effect against the compound. C, a placebo serves as a negative control. It is given to determine the amount of effect that is caused by a therapeutic value by someone believing that they are being treated, but it does not clear biological. Okay. And catalyst increase the rate of reaction. All right, cool.
Basically, we were right.
Yes. Number 2. So, yes, did not know this whatsoever. I could find the stereo centers. The stereo centers was. So I looked at compound 1 and I started from left to right. So I said anything that's in the aromatic ring, especially that has a double bond, will not be in it. We're looking for carbons.
Yeah.
Will not be a sterile center. Then we move on to the second carbon. Again, that has 2 hydrogens, not aromatic. Skip the nitrogen, and then anything that's going to be in that aromatic, well, not aromatic, it's a ring test. Again, we'll have 2 hydrogens, not aromatic. But if we look down at that one carbon that has like the double bond to the oxygen,
double bond to the oxygen.
it's going out the page.
The one carbon that's double bonded to the oxygen. Which one are you talking about? You talking about the one that's next to the nitrogen, that amide?
Yes, going out the page. Yes, carbon 1. So that's double bond to oxygen, and it's also bonded to a
nitrogen.
So that, and then
that's not a stereo center.
That is a stereo center.
The carbonyl group.
No.
The one that's next to the carbonyl group.
Yes.
Okay, yeah. I was confused. You said double bond to oxygen. I was like, wait a minute. Yeah. You're talking about the one that's connected to that phenyl group.
Right.
Yeah, that one.
Technically inside the ring.
Yeah.
So that's one. That's 4 different bonds.
Right.
Yeah, and if you go down to the one that's actually directly next to the oxygen, nitrogen, that's not one, is double bonded to an oxygen. And then the one that's in the butyl group, of course, is not one. So right now we only got one sterile center. So then if we're moving down the line, the next following one that could possibly be one is the one that's connected to the OH group. So you got the OH, and then you got the big old group to the left, and the big old group to the right. So that's two stereo centers.
Mm-hmm.
Huh?
Yeah, I'm agreeing with you.
All right, and then the next one will be the one that's connected to that aromatic ring. So that's three stereo centers. And then we can skip the one that's double bonded to the oxygen because it's double bonded to an oxygen. So now we're back to a ring. So that first carbon that's connected to that nitrogen is an sterile center. And then the one that's at the top that's connected to the OH group, that's a stereo center. The rest would not, because they're either going to be double bonded to a carbon, or has multiple hydrogens. That's 5 stereo centers. Now, apparently, there's an equation.
Yeah.
And it's 2 to the n. N is your number of stereo centers, so it's 2 to the 5th. 2 times 2 is 4. 4 times 2 is 8, and then 8 times 2 is 16, and 16 times 2 is 32, which is the correct answer.
Yeah, when I went, I couldn't remember what it was. I ended up just guessing 32, I believe. But I knew that there was just an equation that tells you that literally just you just plug it in and it spits it out. Yeah. We just have to be able to know where the chiral centers are, and yeah. I'm doing a card on it.
I have so many, I'm not going to get through it. The ones I'm diligent on are behavioral science ones on the new deck. I may get to it, I may not. Which one is it? A or C?
All right.
I haven't done it.
Oh, you haven't made your thing. So yeah. ASP.
Alright, so the question for me is, why do kidney stones form in individuals treated with carbon one? So my logic behind this. So kidney stones, like if you're having kidney stones, that means there has to be some type of precipitation.
Right.
So that means you're having more product formed than there is react. Well, the
More product form?
no, it's not. It surpassed your valuability.
Exactly. Yeah,
So
that's what happened.
if we're talking, so it told you in the very last paragraph, it says, one of the main side effects of prolonged use of carbon-1 is formation of kidney stones composed of calcium oxalate. So, this means that in a reaction, like you can write it out where calcium breaks down and the calcium oxalate will break down into its two components, which would be calcium oxalate.
Right.
Which is what they're showing here. And when they do that, they're all going to be multiplied towards each other. It's not going to be an addition. So that's why I got rid of A and C automatically.
Yep.
So then I was between B and D. And like I said before, if you're going to have a precipitant, you have to exceed your solubility constant.
Yeah.
The only one that represented that was B.
Correct. I mean, that's what I got too. So, yeah.
For the kidney stone, the four reaction produces stones that will be more favorable than the reverse reaction. With the formation of a precipitate solid, this means that the favorability of the four reaction must be greater than the reaction dissolving.
For kidney stones to form, the forward reaction that produces stones will need to be more favorable. This must be a typing error
What do you mean?
in the explanation for 3 on Jack Weston. For the information of precipitate or solid, this means that the favorability of the forward reaction must be greater than for the reaction for dissolving.
Yeah, they're trying to say the four reaction is favored.
Yeah. I just said that the concentration exceeds the KSP. That's how I always understood it. That's how I understood how solubility works.
From Lee Chatelier's principle point of view. So because you have participants, now it's going to favor the four. No. It favored the four reaction, and that's why you have the persistent precipitant. Alright, well, next one.
I'm trying to decide if I want to do something on this. Because basically they're saying that it's because the forward reaction is favored. My understanding was always like, if the concentration is just, I guess maybe they're the same thing.
They are the same thing.
Because it's just the concentration just exceeded the limit.
The reaction is towards the product.
Yeah, and my reasoning was just the concentration of both exceeded the limit of the KSP, so precipitate formed. So I guess it's the same. All right. So now moving on. I had initially picked A for this one about electric. The reason why was because I always thought electric field lines go from negative to positive and the inside of the cell is negative, so the outside should be positive. Apparently that was wrong.
What it was asking, you're on number 4, right?
Number 5.
You're on number 4, sir.
Mine is number 4. Number 5 on my AMC is the one about
Number 4.
we are on number 4.
Yes.
Oh yeah, we are on number 4. Sorry. All right. So the peptide bond between which two amino acid residues is cleaved by, phenylalanine, proline. You just gotta look at the compound.
Yeah, it took me a second because I was like, I don't know what they're talking about. They never talked about it. Like, they never said it was hydrophobic, hydrophilic. And that's when I finally saw it and said protein cleavage. I said,
Yeah.
And then it was a dead giveaway when I saw the weird ring.
Yeah, that was proline.
Yeah, and I said, well, I'm looking for the one that has proline. And then I thought pH here. So I was like, I kind of.
Yeah. All right, now we're on the one about electric field lines, which I got this one wrong because I remember this because I know I picked
I
it.
had no idea.
Here, let's go ahead and set our card up because I'm definitely gonna make a card on this. So I'm gonna grab the passage. And you, huh? Yeah, I guess so. Oh. Protein, sodium, potassium, chloride ion. All right, so are you making your card?
I don't know what's happening, bro.
You don't know what's happening?
No, I'm sure what I got wrong. Again, know nothing about electric field circuits, anything like that.
Oh.
This is. I have no idea what's happening.
So, are you looking it up yourself then? Are you? I mean, it's fine if you want.
You just know who wrote this question. You just put blank. I have to learn all of this.
So
I don't know how I could explain this to me, but do you? Like, imagine if you knew nothing about something, somebody said, figure it out in 2 minutes.
So, well, basically, so all this is, so just as a general, not as a general rule, but as like a rule. So like the inside of the cell, in most cases, is negatively charged.
I agree.
Right? And for electric field lines, the convention is that if you draw like an arrow, arrows leave positive charges and enter into negative charges. That's the rule. So basically, if the inside of the cell is negative, then the field lines have to be pointing into the axon. That's all it's asking you. That's it.
Don't get it.
So like,
I'm about to ask you a whole ton of questions. You're legit just explaining this one question. They asked me anything else about this, I would not be able to answer.
so what questions do you have then?
Why does it always go from negative to positive? I mean, positive to negative.
Because the honest reason is that is what the world said it does. People, a group of people got together and just said, we are drawing our electric field lines this way.
What is an electric field line right now?
Basically, it's the direction of the electric potential. So basically, like, if I were to give like a direction to like the electric force, which is like, think of it like a magnet, right? It's the easiest way to think about it, right? If I have two positive things, right, they repel each other, right? So why is that the case? So think of it as like magnets have a pushing force that they can do, right? That pushing force is represented by an arrow pointing away from it. Does that make sense? So if I push something away, then like I'm pushing it, my force is going away from me, right?
Saying the arrow of the head and the tails are opposite to one another? The tail are...
No, just think about positive charges. Don't add any of that stuff yet. So if I have two positive magnets, right? They're both positive. They repel each other, right? So the reason why is because there's a force I'm pushing out from myself because I'm positive, right? Make sense? Because if I'm pushing...
You're pushing inwards, just to be clear.
I'm pushing away like that. I'm going like this.
So the other one's going the opposite way?
No, the other...
If you're going like this, they're coming towards.
So, just think about one positive charge then. Make it even simpler.
It's not going to repel it.
It's... I'll explain. It'll make sense. So if I'm a positive charge, I'm pushing stuff away from me. So I'm pushing things out. So if I draw an arrow to give the direction of where I'm pushing out, right? So let's play another positive charge and put it next to it. It's doing the same thing. So they're pushing, both of them are pushing out from themselves, right? So they're going to push each other away, right? So that's the point, is the positive charges push out. Negative charges are the opposite. They pull in. So if I put a positive charge next to a negative charge, my arrow is going to go out from my positive charge and into my negative charge. And that's why they attract. Okay. That's a way to think about it. But really, like, you can ask a whole bunch of questions on it and that's fine. But the honest, simplest way to think about this is that, so pull up electric field lines on Google. So you see that? Those arrows? Pull up that third image. Click it. Here. You see that? That is it's honestly, that's just a convention. That is a bunch of scientists just got together and said, this is how we're going to draw this. This is how we're going to draw the electric force between things and the vectors. This is just how it's drawn. There's no real reason behind it. There's no science behind it. Like, oh, there's no research or anything behind it. They literally just got together and said, this is how we draw. That's it. The arrow always leaves a positive charge, always enters into a negative charge. Because if you look at the two positive charges next to each other, all the arrows are pointing out. That's literally all it is. It's literally just a convention. There's no deep lore or deep science behind it. That's all it is.
This is supposed to be. Oh.
So you see that axon right there?
Mm-hmm.
Yeah, that's the interior of the axon interior. So if the axon is negative, then the lines have to be pointing towards the negative charge. So that's why B is right and A is wrong. And that's literally the answer. So yeah, I'm making a card on that. I think you should too. And literally you can either ask yourself the same question. At this point, it doesn't really matter. Or you can just be like, what is the convention for when drawing electric field lines for charges? Is the question I would ask myself. Nah, I mean. What is the convention for drawing electric field lines? That's all that this question is about. And when you say, will we draw electric field lines? We draw the line going out a positive and into a negative. Does that make sense though? That it's not like a deep thinking, it's just something you have to accept. What are you trying to do? You can just copy the image. Like, just right click it and copy. Copy image and just paste it. Why are you so old? She don't know how to use a computer. Yeah, she was born, she's 25. I'm 27.
Worry about yourself.
But look, the point is, you over 20 don't know how to use a computer. Whoa, what was that? All right, next question. All right. So we're all good on that though, right? Okay, so the next one is talking about the function of the myelin sheath, right? Tell me what the function of the myelin sheath is.
It protects it from like the surroundings. It helps keep like the action potential, like so it doesn't lose.
Yeah.
Speed, or it also like it. Okay. Yeah, those are main things. Like Like it helps the electric charge, whatever, not to be lost. It keeps the axon itself from protecting from the outside. Like that. So
Yeah.
So that's what my lunch sheet does. So that's why I kept A. I knew it did not decrease the radius of the axon.
Right.
I knew it didn't produce Schwann cells.
Schwann cells actually produce myelin. It's reverse.
Sure.
Yeah, they do. But I mean, which is actually, they may ask you a question on that one point in time. Yeah. I can't, which ones? I know it's different between PNS and
The other one is
Is it oligodendrocyte? No.
Yeah, so ogiodendrocytes are in the CNS.
And those are the myelin producing cells in the CNS?
Yes, and those produce multiple, versus Schwann's only produce one.
I'm glad you know that. I forgot. All right, but anyways. All right.
So I knew it wasn't B or C. I was like between A and D. The reason why I put D on my list is because I didn't know what capacitance was.
All right, so we're going to make a card about capacitance. One. And then you already know what it does, but you got confused because you didn't know what capacitance was.
Right, and I was like, A is a really good answer, but
yeah.
I don't know what capacitance is. So I want capacitance.
All right, so we ready to make a card?
I have to do some copying and pasting right now. Process.
Oh.
Mouse pad is a little more hard.
You want me to buy you a mat like mine? But it's nice. Oh geez. It is nice. What do you mean?
It's not. It's your definition of nice.
What's wrong with my definition of nice? You not nice. You mean as hell. Quite the contraire.
Disagree.
We disagree.
What is cap? Well, let's just talk. What the hell is cap?
First of all, I need you to pronounce it correctly. It's capacitance. Capitans. El Capitans. Anyways, capacitance is the ability of something to hold an electric charge.
What's the difference between that and an insulator?
An insulator prevents the transmission of charge.
I'm sorry. I'm making.
So when something when something is an insulator, right? That means that charges don't move through it easily.
Okay.
Right? That's why, like with rubber and stuff, the reason why people use it as an insulator is because it literally does not conduct electricity. Charges cannot move through it. That's what electricity is. Pure water is an insulator. Because pure water, it doesn't actually, let's not get into that. But capacitance is different because capacitance is just the ability to store it. So how many charges I can pick up and hold. That's it. That's what capacitance is. Huh? How is it different from a battery? Two different, I think you're generalizing two different things. So the way that a battery stores the electric potential, it stores it in the form of using using an acid solution, and then when you connect the poles, electrons can travel over it. It's a little bit different. Capacitance, so like you can hook up a battery to a capacitor, right? What a capacitor is say in a circuit, you have two plates that are like this. Careful now. You have two plates, right? That are two metal plates. When the electrons travel in that circuit from that battery, those electrons will stick at this plate and they'll just stay there. They'll just stick there, right? The charge is like, say like the battery is my body, and this is a circuit right here. The electrons will go, move into this plate. And
What's that plate?
Huh?
What's that plate?
It's literally called a capacitor,
Oh.
right? So they literally sit here and they just get stuck there, and the charges just get stored in here. That's what a capacitor. The capacitance is how much charge can be stored in this. That's what it is. That's what capacitance is. Which is why I say capacitance is the ability of something to store electric charge. So, yeah, myelin doesn't store electric charge. It doesn't do that. It actually insulates electric charge. It prevents charge from being... For the axon, it prevents a loss of charge, right? And it prevents outside charges from entering in that aren't supposed to be. So it...
One thing I want me to look at the thing was to see that non-myelin versus myelin.
Yeah,
Myelin that has a smaller capacitance.
You said myelin has a what?
And wanted me to look at the chart. The chart tells you the capacitance of a non-myelinated axon versus a myelinated axon. And then a non-myelinated has a higher capacitance than myelinated, so it can't increase. I don't think he wanted me to.
I think there's that, and then also capacitance doesn't just straight up doesn't relate to myelin. Is the other thing.
I don't think that was something you were supposed to just know though. You knew it ahead of time?
Yeah.
Oh.
I knew that ahead of time.
Oh, I said, oh.
So yeah, you should make a card on what capacitance is. Do you have the you don't have the physics book, do you?
Yeah, I do.
Find capacitance in there.
What? You don't have no flipping in there, what?
Don't get antsy. Yeah, I wish we had digital versions. I don't understand why there aren't digital versions. I guess I understand why there aren't. Because then they would just get circulated around Kaplan, physics, MCAT, PDF.
Oh, I'm in the book.
All right, so go to the glossary or the whatever it is at the end of the book and find capacitance.
All right.
Oh, so you found capacitance?
Yes.
So what does it say?
The capacitance of a capacitor is defined as the ratio of the magnitude of the charge stored on one plate to the potential difference across the capacitor. Therefore,
Why are you talking like that? It's making it confusing.
If a voltage is applied across the plate of a capacitor and a charge collects on it, then the capacitance is given. In this equation.
I found the MCAT physics book on the internet. Let's download this. Do you want it?
Nope.
You don't want the digital version? Capacitance and capacitors. What page is it? Capacitance is in 6.3.
You don't spend your money.
Brittany, stay focused.
I'm waiting on you.
I'm trying to. All right. Capacitance. Properties of capacitors. The capacitance of a capacitor is defined as the ratio of the magnitude of the charge stored on one plate to the potential difference across the capacitor. So it gives you that equation, right? C equals Q over V, right? So, yes, that is how you calculate capacitance. That is the mathematical calculation of capacitance, which you should also put in there. You should really have this book. I'm gonna send this link to you because you can't put it in an Anki very easily.
That's why I got my little drawing pad.
All right, so you can just draw it out. So, one is what I want you to do is define capacitance the normal human way, which is the ability of a parallel plate to store charge, right? Or how good something can store charge, whatever. And then I want you to, the next question after that, you're going to like tab under and be like, what is the mathematical equation to calculate capacitance? And you're going to put that into there. Because understanding it both ways is useful. Because one will be able to, if they ask you, like, what is the capacitance, you can calculate it.
Window.
And it is really nice to be able to have a drawing pad. I think I like studying
It's
that
Q
one.
over V, right?
C equals Q over V. Or you can say Q equals CV. Whatever. Cool. Yeah.
Can you stop doing that? Next question, Mom.
Have you put that thing in there?
Yes. I'm fast and efficient. Namaste. Oh.
Number 7 asked us, Channel X transmits only the smallest substance dissolved in the extracellular fluid through the axon membrane. Which substance does Channel X transmit?
So, it said the smallest substance, right? So I'm thinking it has to be talking about atomic size or ionic size. So,
Yeah, which one is it asking you? Because one is you can just get rid of, because
I guess you know what I'm doing.
no. Yeah, I'm talking about proteins because they're just big as heck.
Right, after boom bang.
So now we're talking about what then?
So if it's atomic size, then it's chloride. If it's ionic size, then it's sodium.
So I wish I could find
Because the biggest for atomic size, for ionic size, for atomic size I'll find my answer, is cesium. And then for ionic radius, it's iodine.
hold on. There is a good thing for this in the Kaplan MCAT book. Because I'm actually gonna make a card on this because I didn't know directly. It didn't come. I knew they were talking about ionic size, but I couldn't exactly remember what the trend was.
And that's part I knew. I didn't know which one they were talking about. So how did you know which one they were talking about?
That they were talking about ionic?
Yes, not atomic.
Because in this particular situation, we're talking about ions in solution and the stuff.
Yeah.
So like in the passage it's saying sodium, potassium, chloride ions. The ions of chloride is like, the chloride is a negative ion, potassium is a positive ion, sodium is a positive ion. And it can't be proteins, obviously. So from that, I was like, okay, so we're talking about ionic size, number one.
Is that indicative of an ionic size, not atomic? What's
Because it says ions.
okay? What's that? What would it say if it was atomic?
what would it have said?
Yes.
It would have asked you, it would have had to specify, like in the question stem, that they're talking about atomic size, because the passage says ionic. See what I'm saying?
Yeah, well, that's not good. Then I don't know what to take a question.
You don't know what?
I knew the trick. Which one was the bigger one? I just didn't know which one was the freak we were talking about for this very specific question. So I'm supposed to do a card. If it say ions, it's talking about atomic size.
Well, do you know the trend for ionic size?
Biggest atom for ionic size. It's easier to remember the biggest one because you know which way you're headed. I will tell you that. Stop trying to remember the actual trend itself. So if you just remember that atomic size is always cesium's the biggest, you know it goes to the left to the bottom. And if you remember that ionic size, that iodide is always the biggest, you always remember it goes to the right to the bottom.
So cesium is the biggest ion. Is what you're telling me.
Cesium is the biggest atomic.
Oh, and iodide is the biggest ion.
Right. I stopped trying to remember the actual direction. But like for electronegativity, I know it's fluorine. Easier just to remember the top, and then you know which direction you're going.
Oh, dang it, I just had it. Oh. Wait.
Because I know you know it resets between cations and ions.
Yeah. Atomic and ionic radii. Think of an atom cloud, the distance between two. Are they just gonna get me here is what I'm looking for. Alright. So yeah, iodide is the biggest ion.
That's what
Yeah, I know. I'm talking for myself. I'm literally talking to myself. But
that's why I marked out. I don't know why I'm saying that I marked out sodium ion. I didn't. I marked out proteins and potassium. I was stuck between sodium and chloride. Sorry. Laugh.
Yeah. Being ornery. Give me a second. I am making a card on this because it didn't come to my head immediately. That's goofy.
I'm not done. I got most of the surface of the stuff. Just
so So what's interesting here, so ionic size decreases going across to the right. I wonder if this will give me the whole image. No. It won't. I wonder if, and the reason,
you have the less ZF effect.
yeah, that's, yeah. I was wondering if I should make one on that. Let me reposition this. Start position 1. What the? Okay. So start position 1. ZF is the. Yeah, I want this too. Position and move all the other cards up. Okay. All right.
You basically put that top.
Say that one more time. I'm sorry.
You said
In terms of their trend, I didn't. Are they? I didn't look at it. I guess it is, isn't it? Oh. Well, no, I didn't put that, but if you want to put that, you can. Oh, okay. I see. You're just so smart. All right. So yeah, it makes sense though that we would let the smallest one be looking for the smallest ion. All right.
either way, so. Alright.
Trying to think. Sorry, I wanna, cause I can't, cause you know I didn't, cause it deleted my version. I want to see, because I remember seeing this question of being like, okay, I'm looking for ionic size. Sodium decreases and gets smaller. Maybe, I guess, it doesn't matter. All right, moving on. All right, question 8. What is the closest distance? I had no idea how to figure this out. I had no idea what they were talking about.
Oh.
Did you?
Kind of. So I basically said, okay, they said, and I also highlighted it. So what's the closest difference between the two electrodes that can be placed on the nerve, blah, blah, blah. So I simplified it. I basically said, hey, how can they wanted in meters, look for something that has meters. They gave us a pulse of a constant speed of 100 milliseconds. Meters per second. Mm-hmm. And then the nerve pulse, it says milliseconds. So I converted that to seconds and then multiplied it. That will give you meters.
Where'd you see milliseconds at?
It's on the graph, figure 2. It's 1 millisecond.
It's the length of that. Is the whole length of the graph?
No, it's a length of one dot.
Oh, so
dash to another.
What was your reasoning? Because it seems like that was correct. That sounds really right. Say it again, because I had no idea. I
simplified. Did I understand exactly what it was talking about? No, but I basically said that how I figured out how to work these tests is if it's asking for meters, and they have told you like meters, like a velocity of meters per second, and they're giving you a graph of another like second or something, the seconds will cancel out and you'll just get meters left.
Yeah, you're just following the units.
Right, and that's what I basically did. So I basically looked for somewhere I knew the 100 meters per second would become important at some point.
Yeah.
That's why I highlighted it when I read it.
Right.
So then when I said that, I said seconds have to be somewhere else in this paragraph because otherwise there'll be no other way to calculate it. So that's when I found it on the graph, and then I switched that to seconds, and that counts it out, and that's how I got 0.1 meters.
So What is the closest distance can be placed on a nerve in order to measure the voltage change? So how many milliseconds did you use? One?
Just one. And that was also they give away given the fact that it's still in ones.
But I guess my question is, how did you know? You just knew intuitively that it was one.
Yes, because the answer still has to have a one in it. The only way you're gonna get a one is if you keep a one in it. If you would have increased the
Oh, well, yeah, I guess logically yes.
yes, and that's
but
all I did was lie.
I see.
It's one of those things that to me I think that's a part of mastering the test. That even if you don't know the answer, have you learned something prior to be able to help you figure it out?
I see what you mean. One. I'm making a card on this because I thought, I mean, well, yes, you got it right for the right reasons, it seems. So I knew I didn't know, had no clue. I knew that. So, potential below. Explain why. .1 meters. So now I need to go and understand what the why. So I kind of want to copy this.
Mr. Rogers.
Hold on, I'm trying to understand something. The minimum distance at which the electrodes can be placed is determined by the time for the signaling of the action potential and the speed at which the pulse can travel. Multiplying the time for the action potential, we get a distance of 0.1.
The biggest takeaway, though, if you ask me, is just recognizing that even if you most of the stuff that you're going to get in the passage itself. So if you have meters per second, you can always calculate meters. You can find the other part of the second.
Correct. Yeah, there's I mean, that's something I've realized now too is you don't necessarily have to know how to do it. You just have to know what the units are for questions like this.
Right.
Because you can just follow the units, and as long as you understand your SI units, you can figure out like, okay, well, I need this part. Voltage change right now occurs.
I'm saying and you use a calculator whatsoever.
Because I'm happy for you.
What'd you say?
I'm happy for you. Finally.
It's hard, because I kept considering it. I said, please let me use it. Especially when I tell you gotta keep on for milliseconds, seconds, and whew, it's a lot. Then I had to go from meters cubed to centimeters cubed. And
So the voltage change across the amp occurs over 1 millisecond according to the graph. So voltage change for action occurs according to the graph. Yeah. The voltage change for action potential occurs over 1 millisecond according to. So if you have it a shorter distance, you won't get the whole change. You won't get the whole voltage change if you had it as a shorter distance. Because basically the action potential occurs over the course of 1 millisecond, the whole change. So if I say, so then the reason so you have to have them at least 0.1 apart. Because that's.
Again, Raymond, I don't know the logic behind the question.
I just like to understand the logic because in case I have another one that's similar, I can think about it and be like,
you're
okay.
looking at it that way too. And I didn't. That's what I'm saying. A lot of this test is surface level. You start doing that, you're gonna start realize you're gonna start thinking, oh, I don't have this information, or it's not like the last or something like that. And the only thing I want you to be able to realize is if you have seconds, if you have velocity, you have seconds. You can always find out meters. That's another big thing I was looking for is how the numbers have changed. Like, if I look for something and
sorry. Okay.
listen,
What?
just put milliseconds as one.
It's just 1 times 10 to the negative to the third second, 1 negative third seconds, yeah.
King Henry be dodging and dropping off, then I gotta move back 3 times, and then I gotta move the number back 3 times.
Alright. Next question.
Alright, that's all.
What information about the axon is required to calculate the current? Yeah, I had no idea how to solve this one at all. I was like, what is going on here? So
What information about that? So current, I think Ohm's law, and I think current, which is
V equals IR. That's what I thought too. I thought you would need like the resistance and voltage.
Right. So that's why I said resistivity radius. I was like, but maybe they want you to have length, and that's what it is. That's technically the only difference. So why is it? I guess radius would just be.
So I get like potential because it's like the voltage potential maybe.
Right. I think I was right in.
Resistance, that's your R.
Right.
And I thought it was like, well, and I really wish I would have known what my answer was because I can't remember it. Because it keeps coming up. The current associated. Yeah.
So our answer was right. Think about Ohm's law. It's just I said radius. So why is it length?
Oh, so okay, I see what they're saying. So that thing gave the resistance per unit length. That's like basically saying R over L. So if you, so yeah, R over L, just resistance per unit length, like meters per second.
Yeah.
That's just R over L.
Right.
So if I have R over L and the potential is the voltage, that's what they were talking about, because we did have to use Ohm's law.
Yeah.
That means in order to just get R by itself, I have to multiply it by the length, which is why they say you need the length too. So yes, it is Ohm's law. They just added something to it to make it confusing.
And that's what I was thinking when I put C, and I didn't know what the radius would be for, but yeah.
So I'm putting it in this card because it forces my brain to think like also about when you're presented something like this where you haven't seen before. Because what was tripping me up was the fact of why would I need the length? I just need V equals IR.
Right.
But the way what I needed to think, which was correct,
right,
to think about, having the length, the resistance per unit length, like that's still, R is still there, so that makes sense why I would still need it. Just to have my brain think about like, oh, like something could be added on, so maybe this is needed. You know what I'm saying? Yeah, it was. Our logic, we had to use Ohm's law. I got tripped up on the
length versus the radius.
Yeah, the length part, because I was like, why would you need the length?
Yeah, and that's what tripped me up.
Yeah.
Alright, so he said, current is the charge moved per unit time. It can be calculated with Ohm's law, which is voltage times IR. To calculate current, we need voltage and also potential and the resistance. And we said the conductivity. This answer does not account for variable law voltage and conductivity is the inverse of resistivity. The radius is perpendicular to the current, so it does not help us. Current could be used to calculate resistance. The radius is perpendicular to the current. It will not be useful to calculate. Why is radius perpendicular?
The radius perpendicular to the current?
No, they're saying radius is perpendicular to the current.
Yes, that makes sense. But because the radius is like the distance from the center of the circle to the outside, right?
I agree.
If you're looking at like a tube, the current's going through the tube, but the radius is the measuring this way, up and down. So it is perpendicular to the direction that the current flows. That's true. Why that's important to point out, I don't know, because
maybe that's what makes it just wrong, I guess.
I guess so. Ouch.
Potential is accounted for here, but if we multiply the resistance per unit length by the length over which the resistance occurs, we will have total resistance. That's what it is. The length cancels out.
Yeah. So basically all I did was say I put in the case of an axon, the electrical properties are given below, and I copy and pasted that table and I put it down below it. And then below that I put a question, said what information would be needed in order to find the current of the axon from the information above. Pretty much why is there just a hand in my stream? Yeah. What?
The current.
Current looking thing. Oh, the circuit.
Yeah.
Nah, I just grabbed it all. I thought maybe because I do need to make a card on how to calculate the stuff with that, because they will ask you a question on that. This could be very likely. Circuits. Cap. Yeah, these I need to put it. I'm just repositioning some of these cards. Brittany.
Oh.
All right. You ready? Brittany, are you ready?
Number 10, bro. What's taking you so long?
Nothing. I'm waiting on you.
All right, boom.
What's the pH of the unknown aqueous solution?
It's 5, bro.
Okay.
Keep pushing.
The unknown compound was probably a what? Where was they talking about this?
So the very, very last paragraph.
The research identified an unknown compound, a compound completely dissolved in water and weakly conducted electricity.
So this was my thought process. It said completely dissolved. Strong acids completely dissolved. But then I was like,
Strong acids completely dissociate. Dissolve means like, when you say dissolve,
I thought disassociate. You break down. Bro, so let me, you know? So yes, I was like strong acid. Then I was like, Then it says the pH is 5. We just calculated that beforehand. So I was like, that's not a strong acid. A strong acid is a lower pH, around like 2, 3 something. So I was like, but that could be a weak acid. That's why I got rid of A and B. Right?
that a strong acid disassociates completely.
Right, I agree.
So
let me explain different things. Can you stop chopping and explain?
Well, my reasoning might be wrong.
Can't out. Completely dissolved in water. And when we conduct electricity, solution is fortunately it's dissolved in water. And whiskey will help us with differentiating between the given. So we just have to the pH solution. We know that it's less than 7 acidic. Usually less than 2 is strongly acidic. Dirty way to remember, strong acids fully dissociated. pH of 5 is actually a other So, okay.
Yeah.
So, my second reason, the fact that it was too high of a pH, but I still chose it. I was torn between the two. And I guess I just need to know this is that dissolving, you know what? I'm looking it up. What is the difference between dissociate and dissolving? Difference between disassociate disassociate and dissolve. Yeah. Dissolving is when a compound breaks apart into isolated particles. The second process is when a substance dissociates. Dissociation is when an ionic compound dissolves and breaks into its constituent ions. Constituent ions. Dissociation is specifically the separation of two charged ions in a solution. It is a subset of dissolution, which just means becoming solvated by the solvent. Solvation occurs when the solvent surrounds each individual molecule of a solid completely. When something is disassociated with solvent, it has to be dissolved in it, by definition. Salt disassociates from water, for example, which is how it dissolves in water. Ethanol dissolves in water but does not disassociate. It stays ethyl alcohol. When something dissolves, the molecule is unchanged. It stays itself. When something disassociates, it breaks apart. I think I did it. Get it, but why can't we see it? So then what's the difference? That makes sense? You see what I'm saying?
What are you talking about? A little bit, but say what is yours?
So I get the idea behind it is disassociation means that it breaks into its ions. Yes. Versus if it dissolves, it does not break apart. It stays together as one big compound. My question is, why can't we see it then?
What do you mean can't see it?
So, it's kind of like, why can't you see the particles in water? If you put sugar in water, why can't you see it?
Because they're so small. What are you talking about?
No. Like instead of a precipitant.
Because it's so small. if you put sugar in water, a single sugar molecule. You're asking why you can't see a single sugar molecule? Is that what you're asking?
If the proportion between sugar and water is correct, you won't be able to see it. Pour too much sugar, then you'll be able to see it. It's kind of like when we make the
Yeah.
Okay, my thing is, or like for instance, when we make the lemonade, first it collects all at the bottom. When we shake it up,
Yeah.
we can no longer see the particles unless we put way too much.
Right.
So my question is, that is dissolving, but why can't we see it anymore?
Because the molecules are broken up and separated from each other enough to where they're very small.
They're not broken up in dissolving.
So no, there's like this is one sugar molecule, this is another. When you clump them together like this, they're just next to each other. But when you shake it up and stir and dissolve it, they just separate. Yeah. Somebody can't, because it's so small. What do you mean? You got supervision? You a superhero?
So what is the difference? Solution. Disassociation. No, that's not what I want to say. I want to say, how does is it a reaction? Okay, how would you answer this? I said, how is the reaction of a sugar, 1 gram of sugar placed in water different from 1 gram of salt placed in water? What would you say?
I wouldn't say it's a reaction.
That's what I'm saying. What's the word?
I would just call it like a phenomenon or something.
It's a phenomenon?
It is a phenomenon.
Okay.
I think that's good enough.
What?
That's what I would say, at least.
Explain the
Phenomenon. Do.
That's not how you spell it.
Phenomenon.
That occurs when placing 1 gram of sugar in water versus 1 gram of salt. I hate that. Okay. 1 gram of sugar will dissolve in water. Therefore, it stays one complete. 1 gram of salt will dissolve and disassociate in water. Therefore, it will break into individual ions. Okay. Next question I want to ask is, I just really need to know ratio when like a weak acid starts versus base. Because there is a range, roughly. No. What is the range? Weak base. It can't fall between 7 and 10 because 7 is a fucking neutral. If anything, it's 8 and 10. Why you can't trust everybody? People make me mad. This is from the U.S. Gov of Geology. So it's not telling me weak bases.
Acidic solution.
You move on with that.
No. Focus on what you're doing, Brittany.
You a liar, Raymond. Lies get you nowhere but to hell. And the fiery pits. Judgment.
Please focus.
Fucking in here. Watch out. Ooh. No. Oh. Yeah, no. I'm saying that she just not. The greater the PK, the greater the we get the base. The greater the value of the PK activation, the greater the P value of pH. Acid for a pH of greater than 7, pH be greater than
Common ion.
Another fun question. You have a PK.
Yes.
But that's not the exponent. I will get involved in that. I'm gonna do it.
Describe the common.
You know, if you stop leaving me and tell me about my one question.
I'm looking up something completely different. Describe the common ion effect.
Without you. And you said all amino acids are either weak acids or weak bases?
Yes. Why?
Because lysine has like a PKB of
A PKB of 10.8?
So really weak bases go from 8 to about 10. weak acids go from about 6 to 4. That's my opinion. Yeah, this question is very easy. Did you just leave me again?
No.
Can I explain my reasoning, or you don't care? You don't want.
Brittany, go ahead. I'm listening. Jeez.
So the question says don't tease me.
Jeez.
2 additional compounds were studied. OH, NO2OH, dissolved in water produces a thick solution, and NiOH dissolved in acidic solution. What type of compounds? So, if you go to paragraph dose, it says that if you have a or earth metal with the OH, you have a basic group, and if you have a non-metal with the OH, you have an acidic group. So, nitrogen and oxygen are both metals. That's why I said that is basic. And then
You said nitrogen and oxygen
are non-metals. They're non-metals. That's why I said that one's acidic.
And it produced an acidic solution. Nothing. Continue.
And then for the nickel is a transition metal. So I said that's still a metal. That one's basic. That was my logic.
So my issue with that is that the paragraph specifically said alkaline metals and alkaline earth metals. That's only group 1 and 2. That doesn't include the transition metals. Transition metals do weird stuff all the time.
That's true.
So that's why I would not use that logic. What I think I picked this one because one, I knew that the other one had to be an oxy acid because one, it produced an acidic solution, so it had to be an oxy acid. That's one reason. And it's also, yeah, like you said, it's a non-metal, but I'm doing OH, so the H will get broken. In terms of nickel only dissolved in acidic solution. So what I was thinking was like, okay, so I must have positive charges there for it to dissolve. So that means I need to give negative charges. Does that make sense?
No.
So if in an acidic solution, essentially like I have a bunch of hydrogens floating around, right?
Correct.
Meaning my solution is going to be like positively charged.
I agree.
In order to dissolve something in that, I need to have negative charges.
I agree.
So it only dissolved in acidic solution. It only dissolves when there's positive charges.
So it has to be.
So it has to give negative charges.
So it has to be.
It has to be a base. See what I'm saying?
I see your logic.
Yeah, that was my reasoning. Now, Jack Weston,
Oh, wait.
he said something a little different. The first one is react to oxy acid, blah blah blah. But the nickel dihydroxide, whatever you want to call it, I don't know what it's called, did not produce an acidic solution. It dissolved in acidic solution. We know acids dissolve in bases and bases dissolve in acids due to the common ion effect. I was trying to figure out because my interpretation of the common ion effect is that if two different things are added to a solution, but they share an ion in common, it affects the solubility, right? And whichever one has a lower solubility will precipitate faster. That's what I understood as the common ion effect.
I'm not sure how you're explaining it. Maybe I'm missing it, but how I've already explained it is how I understood it is if you this is my reactant, this is another reactant, this is my,
You should see this. Anyways, continue.
this is my product.
Okay.
Right? So then if
The reactant is on your left hand?
Yes.
And that's your product, the other
this is
one?
my product.
Okay.
So if I add in more something that has the same quality of this or the same product, then I've added more of this. This is why this precipitates, which technically shifts the reaction back to the left, back towards the reactant. Make sense? So you've added more of this, which outweighs this.
That's not how I understand it.
That's how
I don't know if that's right.
it is.
So the way that I think of, so when I think of common ion, I think of like, say like I have two salts, right? Those salts have say calcium in them.
Okay.
Both of them. Say you have magnesium chloride and sodium chloride, right? Both of them have calcium or chloride in them.
Yes.
If I add both of those to a solution, I've added in the same amounts. The one that has a lower KSP will precipitate faster because I'm adding so much more chloride. I'm adding a double dose of chloride because that's the common ion part
I
to me.
agree.
Yeah, that's how I always understood common ion effect. Hold on, I'm gonna just pull it up. I'm gonna pull it up because I was just looking at that.
But get it. I don't know if you're just explaining it weird.
So look at this. You don't have to come into the camera. So you see.
Where are you pointing?
Hold on, I'm gonna make it bigger. Once I find this. Okay. So over here. This one right here. So if you look at this, right?
I agree.
These are two different solids that I'm adding to a solution.
I agree.
Okay, now I see why you're saying it adds to the reactants. Because you're adding two things.
Yes,
of
now you
fluoride.
know that. Right, and that's why it precipitates.
Yeah.
And then it shifts it back to the reactant because there's so much.
Well, you're adding this and it shifts
this
it.
dissolve less.
Yeah, it makes it precipitate. It's the same thing.
No.
If it dissolves less, then it'll precipitate.
Yes.
Yeah. Yeah, but so what I say is two salts with a common ion in solution shift equilibrium to the left, decreasing solubility.
I agree.
Yeah, that's how I understood the common ion effect.
Okay.
But over here on Jack Weston, they're saying that, like, because of they're saying we know acids dissolve in bases and bases dissolve in acids due to the common ion effect. And I'm like, how does that relate to the common ion effect? That's what.
Question number 12. It's theorized. It's a atom. Yeah, we have two options: either produce acid or a basic solution. The first paragraph says that the molecules are either oxyacids or basic. This means that the molecules and bases will produce a basic solution. If it's oxyacid, it will produce a acidic solution. Let's use it for blah. Dissolves in water produced. Well, if that's only in a acidic solution, unlike
Hold on, I gotta use the bathroom real quick.
did not produce in acidic. It dissolves. You know that acids dissolve in bases dissolve acid.
But see how I was like, how does that relate to?
I see your point.
Yeah, that's what I was trying to figure out. What I had to do with because by technicality.
You sit there. Yeah, I think we can just ignore that. See what AMC says. So the first substance is nitric acid. When such dissolves to generate acidic solution, the bond between oxygen, hydrogen, the structural formula breaks into the substance dissolves, making the oxy acid. The latter substance is apparently insoluble in neutral water, but will dissolve in the acidic solution. This behavior is typical features of a basic anion. The bond between nickel and oxygen breaks between the Okay. Alright. Yeah, my reasoning was wrong for the second part. Wrong as hell. The noises you make over. Alright. You ready to a card on this? Why? It may be wrong. And you're diving into something as if we have just about a month to figure this out. You may have time to do that. I still got 15 more points, about 20 more points to put on the board. Alright. I don't got time to be learning everything. I'm trying to get most of the basics. So, you can say that. So, what's going on? Why don't you get the Yeah. And I was talking to the left. I had to. I know after that one happened. And scarred ever since. So, hold on.
I'm a kitty.
It's Professor Dave. Let's learn about the common ion effect.
He knows a lot about the science stuff. Professor Dave explains.
As we continue to learn about solubility and precipitates, we are beginning to understand ways that we can predict or even control precipitation. One such approach we must understand involves something called the common ion effect. So let's learn precisely what this means. The common ion effect is an application of Le Chatelier's principle, which we learned all about in an earlier tutorial. So if you need to review, check that out now. Otherwise, we know that under this principle, which describes the behavior of equilibria, if we were to add an additional amount of one of the components in an equilibrium, the equilibrium would shift towards the other side, using up some of that additional component and creating more of the substances on the other side.
We always say light dissolves light.
Let's now look
Mhm.
at
They're not light.
between, say, silver iodide
What do you mean?
and aqueous silver
Basics and
iodide ions.
opposites.
We say like dissolves like in terms of whether they're charged or not, whether they're polar or not. If it's charged, it's polar. We're not talking about like, because by that logic, then positives would only dissolve positives, which isn't true. Yeah.
We are interested in
Dissolved
forming
in
a
acidic
silver
solution
iodide
near the OH.
precipitate. One way we can see it
Fine.
shares a common ion with silver iodide, that being the iodide ion. If there is more iodide ion in solution, that will affect the equilibrium, and it will shift left to use up the excess iodide ions. If the equilibrium shifts left, that means more silver iodide precipitate will form. So this is a method of promoting precipitation. Let's look at this more quantitatively. Cadmium sulfide has a KSP value of 1 times 10 to cadmium, as it is present in both compounds. We can then, let's just call it 0.01, which without the cadmium bromine solubility, and so I can keep making contact.
Hold on.
You went for a walk?
Mm-hmm. Asked me at the wrong time. Um. Autonomy Mosu. Hold on. Sorry, no. In my solution, restate using this. The water, but also the deprotonate acid will be negatively charged. That's just explaining stuff that's already, you know. All right, we can move on. I was trying to find an explanation of the common ion thing, but I guess it's whatever. Only dissolves. I guess it's whatever. Okay. So a certain central atom A of a compound was most likely.
So yes, I said that we said the pH of the solution was 5. So I said acidic, and they said if it's a non-metal, I had to guess.
So I think AO. So yeah. So because it produced. It was made an acidic solution, right?
Huh?
The compound that he added made it. Was he trying to figure out made an acidic
Where
solution?
did you see that?
Because it says the researcher tried to identify an unknown compound, AOH. The compound completely dissolved in water. That's what they're talking about.
Doesn't mean it's acidic.
Well, no, because the hydrogen ion concentration of the unknown aqueous solution that he did was 1 times 10 to the negative 5.
Oh,
So it was acidic.
okay.
Yeah. So it's an oxyacid,
Yeah.
but we know that the oxyacid only comes if it's a non-metal. So yeah, that's what yeah.
Couple in a row. All right. So, are you on 14?
Yes.
So for this one, I basically said that squalene is the final one that you get in the cholesterol synthesis. You know, like isoprene, monoprene, diaprene, you get squalene, and then you get your cholesterol. So I looked and I said, okay, well, which one of these are cholesterol derivatives? And I said steroid is cholesterol derivatives. The perglycerin are fatty acids. Phospholipids, fatty acids, triglycerol, fatty acids. Yeah, there was the only one that was a cholesterol derivative. What is all the typing, my boy?
Oh, wait. What molecule is our prostaglandins made from?
They're soluble lipids. Fatty acids.
No, I'm just I'm adding stuff to something that I already have. Because I didn't make this connection before.
What connection?
That prostaglandins come from arachidonic acids. Anyways, but yeah, I picked steroid hormones because the terpenes are precursors to yeah. And then that's in steroid hormones and whatever. All right. The concentration. This is a Stoke question.
So,
Calcium chloride.
what I wrong. Should have multiplied. So I should have took the okay. I don't know how you describe it, but when it dissociates, it makes calcium and chloride. Calcium has a overall charge of +2, and then chloride has an ionic charge of -1. So to make them even, you would have to have 2 fluoride to make up for the 1 calcium. So
Yeah, it's just a Stoke question. You got to do the dimensional analysis thing. Know what I mean? You did that though, right? You just didn't multiply by 2?
Yep.
Yeah. Oh, you gonna make a card on it? Like that. I'm like that. I'm like that. I like that. Sorry.
I'm done. So calcium is written as blah 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 blah.
Mm. Dex.
Next question. Woo! Alright, so it says addition of which disaccharide, blah blah blah, will not result in the deposition of a shiny silver mirror of the walls of the reaction. So my thought process was, what is different about all of these, at least from what I know. So
Yeah, that's one thing I've noticed. All right, go ahead.
So sucrose is a non-reducing sugar versus maltose is a reducing sugar, lactose is a reducing sugar, semicellulose is a reducing sugar.
So, but how do you know?
How
How can you tell that they're reducing sugars? Because that's what I did too. So how do you tell?
They have to have a free anomeric carbon in order to.
Yeah, exactly. And all three of them do. The only one that's any different is sucrose. Yeah. Because I didn't really know what I remember seeing something about how you can tell if a reducing sugar is present because that mirror, which actually maybe I might make a card on that process. Just because I do have heard of them asking that. The AgO2 thing or Ag2O is a process that you can use to tell if an aldehyde is present. So, or something is either an aldehyde or something. I couldn't remember. Huh?
Hemiacyl group?
Is that what it is?
I think so, yes. Yes, and it's also used to test for reducing sugar. So Jack says, I've never been a huge fan of carbohydrates. That's unrelated. So
Never been a huge fan of what?
carbohydrates on the MCAS because they always felt unnecessarily complicated. So the solution mentioned in the question stem is a silver oxide and is used for testing for reducing sugars. For sugar to be able to reduce another compound, it should be able to be oxidized. Practically, this will occur when the ring of the sugar is open to add a hemiacyl to form an aldehyde intermediate. To find a hemiacyl, we look for an oxygen containing a ring with an alcohol directly attached to a carbon that is adjacent to the oxygen, the anomeric carbon. The disaccharide below that does not have a hemiacyl will not be a reducing sugar and will not produce the silver mirror when reduced with silver oxide. This is the disaccharide we are looking for. So my logic was right.
Yeah. Give me 1 second. I just want to verify something.
Literally the whole thing and I think that's your problem. I really do. Is you're trying to know everything. And there's just certain things that they want you to know that the one non-reducing sugar, sucrose.
Oh, maybe I'm getting this confused with something else. Oh no, it's this one. Toluene says utilizes oxidation, and a positive toluene says aldehydes reduce Ag to metallic silver. When many Ag used, aldehyde is rarely oxidized, indicating a red precipitate of below.
I wasn't sure I got this one right. Stuck to my guns.
Let me get my...
You know, I think so this one's fine.
What?
That's what you said, this Chem and Phys.
Yeah, people say that this Chem and Phys is harder.
And it doesn't feel that hard.
I know. So I don't know if they're wrong. Or what? Is this the net charge one you on?
Yes. So the only thing that I was iffy about is usually when they ask this question, they do it a physiological pH of 7. When they said 8, it almost threw me off. But I said I'm gonna stick to what I know. So what I know is if it's a uncharged compound, it does not add to the net charge. The only ones that do are either basic or acidic. So we have arginine, which is a basic amino acid. So basic amino acids add a +1.
Why are you talking like that?
So we have a +1 in the group as of right now. Alanine is a hydrophobic, non-polar, uncharged amino acid. Same thing with phenylalanine. Same thing with leucine. So that means the only thing we have overall is +1.
Yeah.
So I wasn't sure with the whole 8 thing because I was like, do I subtract 1 to put it back at 7? And that's why I was kind of torn between B, but I was like, I don't know nothing about that, so I'm still with C. What are you taking a note on now?
I'm not taking a note on anything.
What are you doing there?
I am looking for something in my cards. Why are you hating on me?
Because you were taking forever, bro, and we don't still got like over 200 questions to do.
You don't have.
You would keep going back editing cards.
Are you?
I am.
Uh. Benedict. All right. Next question.
Okay, so this is talking about.
How do you be reading the questions so fast?
I've been waiting on you, remember?
Oh, researchers use reverse phase hypermobile time.
And I remember the question.
Compound 2 will elude first because it does not interact as favorably with the stationary phase.
You ready?
Yeah.
Okay, so first of all, they gave you all the answers you possibly need.
Yeah, they did kind of cheat the system because they pretty much told you what it does.
Because I do forget like which one is
Yeah, because that's what came across my mind too, and I was like, oh shit, I don't remember
Right.
which one does which and what.
I do forget. So yes, so they said that the polar phase, the polar is the mobile phase, and the stationary is the non-polar phase. How I think about it is, if you are non-polar, that means you're gonna stick to it harder, and you ain't gonna go moving far. And then if you polar, you fly, you moving, you going far. Okay. With thin layer chromatography or liquid chromatography, you want a small RF. That means you move the littlest. That means you bind to the stationary phase the hardest. with that logic.
Wait, you want a small RF if you're doing
Yes.
TLC?
Yes. You want
I thought the RF was a distance.
No, you're thinking of retention time, and that's gas chromatography.
No.
Yes.
Hold on.
Yes. I just got this question wrong. I got you locked up. You want a small RF. That means it traveled the least amount of distance. Because it bind it tighter.
Hold up. Hold on, bruh. RF is the distance traveled over the solvent.
So you
Distance molecule traveled over the distance solvent traveled. Okay, so it's
you want a small RF. That means it traveled the least amount of distance.
okay. Yeah.
So when I say thanks for comp, I mean it. Oh my god! I just took organic chemistry and got an A, my bro. So with the logic I just said before, you have to fact check it. Then we're gonna look at compound 2 versus compound 1. We scroll up, we see that compound 2 is more polar compared to compound 1.
Right.
So if that's the case, that means compound 2 is going to have a bigger RF, meaning it's going to move faster than compound 1. So it says that's why I want the compound that says that compound 2 will elude first, meaning that's going to be moving faster because it does not interact as favorably as compound 1 with a stationary phase. Because the stationary phase is going to keep holding on to compound 1 because it interacts so tightly.
Right. All right, let's continue. With the data which data suggests that the difference in compound 1 housing between are not due to changes of binding affinity toward.
I gotta read the question. What data suggests that the difference between compound 1 metabolism between the variant are not due to changes in binding affinity?
So what tells you that?
What data suggests that the difference between compound 1 metabolism between the variant and wild type or blood are not due to changes in binding affinity? Compound 1 is still eliminated from the body, expressing the okay. Did I understand A, C, and D? Hell no. However, I did get B. B didn't make no fucking sense. This was my logic. My logic is, what is binding? KM is binding affinity, how tightly it binds. So if B is saying that they don't differ in KM, that means they have the same exact binding affinity.
Yeah.
If they have the same exact binding affinity, that means... Wait, pause. They will bind the exact same. They'll have the same exact KM, which is not what we want. It says due to changes are not changes in the binding affinity. The enzymes are due to changes in the binding affinity.
It's just asking you what tells you that the changes aren't due to binding affinity. Yeah, and we know since the KMs are the same, we know that the differences. Yeah.
Yeah.
That's all it's asking. Yeah.
Yes. Yes. All
And
right.
we can tell that by looking at the KM. All right, continuing. If the data used to generate the kinetic parameters in table 1 are displayed in a line with a blur plot, the plot would show that the y-intercept.
The data used in the table 1 were to display the line. Okay, boom. So we gotta go up to table 1.
Yeah.
Table 1 shows that the KM changes and the Vmax changes. So, but right now it's talking about the Y. Well, it doesn't change much on the KM, but on the Y-intercept, on the Vmax changes a lot. So the Vmax is on the Y-axis. So we're looking for the information that basically says that the Y-axis is changing for all three.
Yeah.
And that's the one I chose.
This microphone is so sensitive. But continue.
That's it. That's why I chose that one, because I was looking for
The Vmaxes are different. Yeah.
So they all have to change on the Y.
Yep. The point where it crosses the line on the Y is different for all three.
Yep. All right. So it says the overall reaction scheme for enzymes of the CYP450 enzyme family is shown with the R representing the substrate. In this reaction of NADPH functions as so. Oxidizing agents. Oxidizing agents means it oxidizes another object, atom, compound, whatever. Itself gets reduced. Reducing agent means that it reduces another compound or atom. Itself gets oxidized. Catalyst is a reaction like the bowel. It's electron deficient, so it gets attacked by this. Okay.
It's a reducing agent.
Okay, I was there. Okay. So if you're looking on the reaction side, the NADH, and you look on the NADPH, and you look on the product side, it lost a hydrogen. If it lost a hydrogen, that means it got oxidized. And we said before that if it itself gets oxidized, then it's a reducing agent. Now, I was a little shaky about this, but I figured it out. Because I knew C was definitely wrong. And everything after that was a little wonky. But I really should have marked off. I don't want to know. There's actually was a hydrogen in play. So, this is what I did for this. A little bit longer, took me 2 minutes to figure it out. So, I checked off C, double replacement, because I was like, only one thing is a single replacement, if anything. So then, I said, oxidization. Ain't 100% sure what that is, but I was real torn between Lewis acid bases and oxidation. So Lewis acid means that there has to be an exchange of electrons. Boom, bang. But I was like, I don't know how to figure that out for real. So I'm gonna go to oxidation and reduction, see if I can prove that. Okay, we're gonna start there. So then I looked at magnesium, and I know magnesium has a +2 charge. When it's bonded to something that's more electronegative, it basically has to fill in whatever's left. Yeah. So, well, it kind of has to match the image. That's how I like it. So, when it goes to the product side, you have chlorine. Chlorine has a -1 charge. So then when that magnesium becomes a +1 charge. Yes. So, we see magnesium go from a +1, +2, to a minus to a +1, meaning that it gained an electron. And that's an oxidation and reduction in the thing. That's why I chose that.
Yeah. I'm just trying to figure out more why B was wrong. Because, you know what I mean?
Yeah, I hear you.
Because the movement of I picked A also, but B is like movement of electrons to me. Oxidation reduction is also kind of movement of electrons to me, right? Let's see what
Yeah, that's what I'm reading now.
Jacko says. And the sharing of donated electrons between ionic.
I think it's just because it's better.
Yeah, it's because it's a better answer. This is what sometimes sucks about this because no. Well, I kind of think I've understand it because someone said I think the issue is CL is not tackling anything initially. No, I didn't. It is first necessary to oxidize okay, I think I see what they're saying. Before, so yeah, technically you could say that like CL, the electrons from CL, even though technically it is just a better answer. There's multiple reasons why that's not a really good answer, right? One is the fact that like MgCl, the bond, like Lewis acids and bases involve bonds that are like shared, they're covalent bonds. Mm-hmm. And that MgCl is not a covalent bond. So that's one reason why that's not really correct. The other reason is what initially starts the reaction is the fact that magnesium is oxidized and it loses electrons. And the hydrogen gets reduced. That happens first. And then that happens first. And then the Cl attacks the magnesium. But even then you still can't. I see what it's saying now.
Alright, moving on.
I don't understand why you're trying to move so fast. I got stuff to learn. Why can't the formation as a because I do think that is an important thing to point out, because that's something where they could trip you up on. The fact that like Lewis acid and base reactions involve creating covalent bonds, number one. And all right. You on question 23? Suppose that at the end of the reaction, either swing system or higher. Suppose at the end of the reaction one. Compared to the ambient, sorry, I'm trying to read this. Compared to the ambient pressure of the gas inside the burette would be lower. All right, go ahead. Huh?
So this is just Boyle's law. So they increase the volume, but Boyle's law says that volume is inversely proportional to pressure. So if you're increasing volume, you're decreasing.
My thinking is that when you have this situation has to do with to me, it's kind of like a physics thing, where if you have like a situation, like, because it's basically like a fluid barometer to me. If the atmospheric pressure, basically what happens is the pressure of the air pushes on the fluid, right? And if you push on the fluid, it pushes the stuff in the tube up.
Mm-hmm.
So if the stuff in the tube is higher, like in the air, that means that the pressure pushing it into the tube is higher. So that's the ambient pressure. So when you compare the two, that means the pressure inside the burette would have to be lower. You're talking about Boyle's law then.
But that's the same concept.
Boyle's law is P1V1.
Boyle's law, just the idea behind Boyle's law basically says that pressure is inversely proportional.
Yeah, but I don't think that applies to this question. Because that's talking about like if there's like a change in pressure or volume.
There is a change in volume.
How would you calculate the volume of this?
The volume, it says, went 26 degrees higher. In the
26 centimeters, that's just a linear length.
Yes, which is volume.
No, volume would have to be centimeters cubed. See what I'm saying?
I'm saying that if you look at the right notches and you can count 26 inches, those are your volume.
That's not your volume. It's really not, though. How do you get volume? So
I literally said, okay.
But it's not a convincing okay. You sound like it's. But no, like if you just have a ruler and I say 26 centimeters, how is that a volume? See what I'm saying? Hello?
I said okay.
I just don't want you to get confused in the future.
I heard you the first 5 times.
The level inside is higher than outside. This results from the fact that the air pressure outside is higher than the pressure inside. Right. Pressure builds on the inside by the generation of H2G, which lowers the liquid level. When H2 stops being generated, the level inside the liquid stops moving. Yeah. So does that make sense? And that was your logic. Well, I mean, technically your logic was the Boyle's law.
I mean, that's still, do you understand how that's still the same exact thing, right? If you realize the volume inside the barrette's going up, right? They're saying height. That is still, the fluid volume is still going up.
I mean, yeah, you're right, but if you are asked, if that is where your mind goes, and there's like, say for example, I don't know. In this situation, the volume would be related to the height that it goes up. There's a relationship that you can reasonably say is there.
I literally just said that.
But the point is, like, if you are asked, like, say for example, if this goes up this high, right? If it goes up 26 centimeters,
You have to know.
how would you, if I told you, give me the atmospheric pressure, then how would you figure that out?
I wouldn't know that. I'm not saying I know that. What I'm saying is the logic of if you increase pressure, if you increase the volume, pressure has to decrease. That's literally all I'm saying. As far as the way it's applied in this situation, yes, it's slightly different. Do I get the concept? Yes, because if you're increasing pressure on the outside, that liquid has to go somewhere, and it's going to go inside the barrette.
Yeah.
If the barrette was closed off, it would go on the other side of the container. It's just one of those things that it has to go out. My point is, I get the concept. It's not a hard idea to understand. Would I know how to calculate it? Even with this question, I still wouldn't know how to calculate it. There's some equation probably somewhere that will tell you that you need to take the difference of how far it went, and then calculate the pressure. Somehow you got to calculate the pressure inside the barrette to get the ambient air on the outside.
There is an equation, yes, but all right, let's just move on.
Why? You didn't like my reasoning. I mean, I can see it here. It says fluid height plus barrette gives you ambient air. They literally just wrote it out. Jack did. Hello?
Yeah, I mean, yeah. I mean, do you feel, I mean, you got it right.
That's not good enough. You're like, even if that just has to be something that I don't even know if it's even right. You're like, I have to go find it in my card deck. You on the oxygen machine? What is that noise?
I'm on the oxygen machine.
It sounds like an oxygen machine.
What was the oxygen machine?
You took my cards.
Um,
If you were given second part was like a difference. I mean the first part. If you in an experiment you have a burette in a aqueous solution. Inside the burette. So, in a given experiment, the burette is placed within a aqueous solution with some liquor. The after ambient pressure is applied, the solution inside the beaker rose 26 centimeters. What does this change the pressure within the beaker, in the burette? The pressure within the burette lowers because to allow the displaced water called ambient. Yes.
yep.
Okay. If given the solution height and the change in
No, I didn't, Brittany. I didn't do anything.
You definitely stop doing that.
Yeah, we went past that a long time ago. Yeah, I'm ready.
Alright, so this says, how should the ideal gas law be rearranged to mostly use the values from the passage to calculate gas law? The ideal gas law equation is PV equals RT. The
Algebra.
yeah, so you try to get R by itself. So
Yeah. Algebra.
yeah, alright, so
Yeah.
alright.
I think you get the next one wrong, but
Well, you know, I literally got like the last 10. So, alright, it says, what was the major. So it says, what is the major goal of the experiment in this method?
this one was pretty simple, right? It's they're just asking, did you read it? And the point of the experiment was to determine the ideal gas.
Yeah,
balance.
I wasn't 100% sure, but I was like, that one feels the most right. Like, that's what the whole passage is about.
Yeah.
And it says that that's what you use the experiment to do in the passage. It says the ideal gas law or constant R can be found measuring the volume that's given in a gas occupies a certain blah blah blah. So it kind of told you. So that's why
C.
I chose it.
C.
How is that so right, nigga?
Hey. Don't call me that.
Tell me I got it wrong.
uh,
This was mathing. I will explain it later. Let me.
damn.
I do know why I got this one. Most of the math stuff.
I see. Being dumb.
I wanna tell the world about you just so they can get jealous. And if you see a fool,
Some of these songs are the jam for real. You know, let's watch since we're taking a break, let's watch a match. So yeah, let's watch the match. So playing this Beef-O-Rama. Yeah, I played him a couple different times. I'm curious because like when I was like first, you know, when biking came out, everybody was playing biking, so all you could get was biking matchups, just mirror matchups everywhere as far as the eye can see. So this was the first person that I played that at least stuck to their guns, which I thought was pretty cool. Let's see here. Yeah, Rosanshin. I'm not pronouncing it right. Move dummy good. I like that move. Definitely need to figure out, like, I don't know, it's been a while since I played her last week. I just been studying a lot, so I haven't been able to, like, well, hold on. Because I just made the realization. I am not even on the game screen. Let's pull this up. And all right. So what I need to do all right, starting over. So yeah, this was like when I was playing biking last week, because you know biking came out, literally every match that you got was just a bike and mirror match. That was literally it, which was cool. You know, it's a new character, so everyone's playing a new character, but I really want to see how she does against just other people in the cast, right? I mean, that's kind of the point. She's fun to play though. She's super fun to play. There's a lot of really cool mix-up, and when you get that tether on, the damage goes way up, the combos get real nutty and crazy, the mix-up get crazy. So I'm kind of curious to see if there's, I don't know, certain very powerful setups that you can do to get into tether besides like just throwing. I mean, don't get me wrong, like I think Biken's character as she exists in this game is she just wants to throw you all the time so she can get tether for free. Not for free, but you know what I mean. But anyways, let's continue watching. And I finally got my inputs up. Finally, bro. That was lucky because I shouldn't have pressed that button there. Because I pressed 2S, which can get stuffed very easily. Oh, match is over. Let's see. Let's watch another one. Let's do this over. So, yeah, I played him a couple times. Let's see how this one goes. Keeping distance. There it is, bruh. The JS, the God button, bro. And that's what, I don't know, I just wish there was a better way to get into tether, but I understand why they didn't, because if it was, it would just be too strong, right? Throws. And that's, I guess my kind of thing I need to figure, because I'm not good at the game, is trying to get good hit confirms, because like the heavy slash version of the Kabari is like a combo move more so than anything else. But there's certain situations like, you know, purple RC, eat their input is a situation where you need to do the regular slash version of Kabari. Because you get more damage opportunity and you get the tether, right? It's just a little optimization thing, which has always been my problem with a lot of these games. Well, with a lot of games in general, is that, you know, I'm not like, you know, just play them casually, so I don't super optimize things, but, you know. And I guess the other thing that I really like about Biken is the fact that, like, you can play a lot of neutral with her. Like, it's one of those things that I feel has sort of been retained versus like her XR version, because like it's you want to like move in and out of being very defensive minded and then being offensive minded, right? And like you doing the annoying tactic of throwing tatami mats all over the screen, right? Because it works. Because if someone's being too aggressive, they'll just get hit with a tatami mat, and it keeps them out and allows you to slow down. I feel like she's very good at controlling the pace of the game, which is why I like her so much. Because I feel like most characters in just Guilty Gear in general have a tendency to just want to like impose their will, like day in and day out. Now, granted, as you get better, you can't necessarily just do that, but you know, for the level that I play at, all people want to do is just maul you. So it's nice to have a character that can like just be like, no, you know, and I feel like she can do that. And then she can do the mauling sometimes. Yeah, I need to stop defaulting to cavalry heavy slash version sometimes. I think it's a new character, right? And people can get away with stuff, but I'm not exactly sure how that will evolve over time. So, and this, I think when I was playing, after a while, I stopped doing this because I just like, this not gonna work in the long run. At least doing the 2H into cavalry. Really, I think a better option is to do the 2H into a tatami mat, because it makes it a little bit more safe, I guess. I don't know if it's completely safe, but it's more safe than doing that, I think, to me. Now, granted, I'm kind of speaking off the cuff. It may be like a spacing thing that makes doing 2H into cavalry like more useful in that situation. I don't know. I could be dude, I'm just talking. I don't even know what I'm talking about, but I don't know. I'm just thinking out loud. But yeah. Inquisition, judgment. Pay respects to the palace of Yama. Yeah, the translation for this in English is really dope for her intros and stuff. Let's go back to the replay list. Let me see, how was it when he played as May? I'm curious about that. Big button May. Big button May, you know how that be. Out here wildin'. Throw, cabaret, tether. Now the nonsense ensues, kind of. Yeah, that was so lucky. I'm just pressing buttons. I'm literally just pressing buttons. And doing a couple RCs to make myself seem sophisticated. Yeah. Tether! Alright. And there it is. That's what I'm talking about, baby. We like that. We like that. So, yeah, that's what Tether does. It's like, it just makes her combo stuff go out through the roof, and it's really, really fun and satisfying. She's really fun to play. And like, the thing about it is like, she just has tools like that are just very like straightforward that work, at least as the game exists now, as her character exists now. So I don't need to get back into it and see how she plays against other people now that time has passed, because I think people, you know, it's the inevitability of people trying out something new and then going back to their original main characters that they typically play. Although I think there are a lot of people in this DLC release, I guess you could call it, that I think will switch to biking because, one, she's a favorite, and two, like, I don't think that we're going to have the same issue. Well, not really issue, but it's not going to be as memeable because I think people are actually going to stick with the character. I really do think that, because she's fun. She's fun, man. They made her really fun. Yeah, there we go. I think he plays with May more. There it is. That's a Tommy, bruh. See, that's what I'm saying. Like, doing the tatami mat is the god button, bruh. Burst, get off me. Playing some neutral. And I guess, I don't know. There's a lot of things I need to like figure out to see how useful they are. There it is again. That's tatami mat, bro. It's annoying. It's so annoying to deal with, I bet. But it's so fun to do. So yeah. Let's do one more and then I'm gonna do some study stuff. Counter. Yeah, I keep doing Kabari when I know deep down in my heart of hearts that does not combo that way. On purpose. You can tell it did it on purpose, because if you could just combo into our Hickam into Tether easily, she'd be so strong, I think. Now granted, it's going to be interesting to see how, like, because she does not the only one who gets a damage bonus because of Tether. It's basically like a, you know, you're locked in here with me and I'm locked in here with you kind of situation, because if you get outplayed while you're tethered and you get hit, you're in for a world of hurt versus some characters, which is going to be cool to see. There's going to be some very character specific combos in certain matchups with Biken, right? And I'm really curious to see how like Mei does in this situation, or how Soul does when he gets to hit and Tether when Tether's active. That's what I'm curious about, because their damage is high without it. So I'm really curious to see how they work with Tether tied. I wouldn't be surprised if there were some crazy TODs, but you know. Big buttons, bro. Big buttons. You got big buttons. I got big buttons. So yeah, things like that. Getting the counter hit, but I don't know. It's like you gotta kind of like either set up the counter hit and with some sort of confidence. And I want to say that Cavalry is 0 on. Is it 0 on block? I'm not sure. I have to look that up. But I don't know. Things to think about in terms of how you should structure your defense, which I think it's a really important thing to like talk about. And you know, let's just talk about it now. So one thing like that I kind of like in a prior like sort of video content thing I did, I was asking Guilty Gear community about like the ceiling for Strive, and it's very interesting to me because one person had pointed out like, you know, yes, it's simpler, but now I can't hide behind tech or mechanics to be good at the game. And I was like, yeah, that's absolutely true, because Strive forces you to like get to the mind of fighting games much sooner. You know, I think that's a good thing. I do. And it's in general, like Strive has really at least shown me that like, hey, you need to think about how you're structuring your offense and what options you have off of like any given button. That's how I tend to break things down now, especially when I go through and look at my like footage of me playing. Is, you know, I got counter hit there. I kind of got counter hit there because that's not structured well, right? In terms of like, that's minus on block, you can't press a button after that, or why throw that move out because it's minus on block, right? Or maybe you need to space it correctly, and then I think, well, okay, if I space it correctly and this blocks or hits, you know, what do I do based off of that block or hit? What should I be pressing next to sort of keep my opponent in a position where they're at a disadvantage? So like, sort of like the structuring of your offense, and then the same thing applies to defense. It's something to really think about, and you get exposed to it a lot in Strive, and it's something that carries over to a lot of different games, right? So I think it's a really good game for people who are new, and for people who have been playing for a while, because there's things that, you know, I feel like I'm thinking about more internally with Strive than say I have with other games, right? But also with other games, there's so much more tech I have to think about. You know, it's just a weird thing that came across my mind one day when reading through that Reddit post after I had kind of posted it, but I don't know. There's a lot more of that. So like, you know, after things like that, right? Because I did like the 2H and I did nothing after it because it just got blocked and I get hit because it's minus. I don't know. It's one of those interesting things where you sort of have to gauge what the the risk and reward is, and then also figure out, is there ways to minimize my risk? Like maybe I should have thrown out the tummy mat after that hit, or maybe I should have just always buffer into the tummy mat after 2H, or do something different. Know what I mean? I don't know. Totsugeki. That was almost cool. So yeah, like things like that. I really should put something. I need to put something after it. Bye bye. Yeah, man, biking can keep you in a corner, man. Like that's one thing I noticed too, is it's way easier to put people in a corner. Also, I should have supered there instead of whatchamacall. I really should have supered there, because that would have just ended the round. I don't know. But yeah, all right. Enough of that. Enough of that. Enough of that. Enough of that. So, I'll put that there. But yeah. So what I'm gonna do. So this beat is, first of all, this beat is tight. Secondly, did he use a Skype? Did he sample the Skype call? That's dope. Waiting for my study partner to come back so we can get our move on. A move on. And we can get our move on. Yeah. This is my favorite kind of music. I love the neo soul hip hop vibe. I like the song a lot. What song is this? Or not song. Definitely downloading this. Definitely. So this right here, man. Some of these songs are bangers. Yeah. Man, this song came out 5 years ago. That's wild. This song is it's a heater. Ka boom 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 ka boom. Anywho. I got shorts on. I wish I had pants. I gotta do laundry today. You ran about what? A present system?
Prison system.
You want to talk about the prism system now?
After watching that video, yes.
Is that why you were in the bathroom for so long?
Yes.
You need to focus. What?
First of all, we never moved to Pennsylvania.
Okay.
Their reason is, most places have life with parole or without parole, depending on the severity of your case. Theirs is always life without parole. Second of all, they don't believe in, let's just say it like this. If I were to murder somebody and you didn't know I was going to go murder somebody, I just said, come on, and I killed somebody, you would still be convicted of first-degree murder.
Oh.
Yes. So there are people on, the people that were speaking, there are women on there that have life without parole. And she was legit sitting in the car. No prints on anything, nothing. Didn't have a clue. They still convicted her of first-degree murder.
Why? That doesn't even make logical sense.
Their justice, that is their rules as far as justice. If you're technically a co-conspirator. Even if you know nothing about it. If they can prove that you were there, you will get convicted as well. So, the three women that came on and talked, one of the ladies, yes, she was 18 years old. She had married an older man. He had her sitting in the car. He went and killed her. He killed his own ex-wife. Came back, put her in the car, and then he kind of explained to her hey, I just killed my ex-wife. Come help me wrap up the rest of the boys, and we're gonna go bury her. Of course, she's in shock right now, and she goes with him, and they bury the body or whatever. And they basically convict her for first-degree murder as a co-conspirator because she didn't report it. But she didn't actually kill the person. But she still got life without parole. Doesn't make any sense.
Mm.
The other person, this is a real sad story. You can hear when she talks. She has a mental disability, to the point she talks very slow. She can't read, she can't write, she can't do anything. She, basically a group of friends just asked her to come out drinking. They basically went over to the person's house, had no idea, and the girl basically runs in and kills the other girl. She has no idea, and to help, she pulls the girl off of her. She gets blood all over her. They still convict her of first-degree murder. But her prints was not on the knife at all. The thing about it is, so they knew she had a mental disability. So the first judge basically says, I'm not, and she had pled to third-degree murder. The judge, the first judge, just basically says, I know she has a mental disability. I don't want no parts of it. But he passes it on to another judge. The other judge basically gave her mercy. And life without parole. So, the thing about it is what they're basically saying is, in order to basically just get out of prison, just get parole, you have to, you have to have the like the appeal and everything else or whatever. But it has to be unanimous. It's not like a 4-1. It has to be 5-1. Even then, it's still a 5-year process of just doing your application between them actually reviewing it, you getting your statements, proving that you've changed, blah blah blah. So they said, and then even after you go in front of the board to try to appeal your case, then it has to go to the governor, and the governor has to sign off. And the governor actually came on. He says, in my whole time, I've never seen a woman released, like a person released from jail on parole that has life without parole. And I think, and one of the guys, he was a prosecutor. He was like, yeah, like I was a person that was all for basically the minimum maximum sentence. Basically, if they say you can do 10 to 30 years, they want you to at least get the 10 years. Or was it the maximum, minimum? Minimum, maximum? He was all for the sentences. I think he was like on the 30 end or whatever. And his idea was, I thought I was making, he was like, I realized now I was wrong. And I thought, he's like, back then I thought I was making the streets safer. No! That is not what that means. If you don't think somebody can sit in prison for 10, most people after you sit in prison for 5 years, you learn your lesson. Let's just start there, okay? Like, you don't have to spend 10, 30 years in order to learn your lesson. Second of all, I don't believe prison system should be set at a certain amount of years. Like, it should truly be like a rehabilitation thing, if that's what the goal is. So if you look at that person, you can, like, there should be actual trained therapists sit there and look at people and say, they have not changed. Their sentence still need to be extended. They still need to stay here. But if you can look at somebody and says they're no threat to society, they should be released. You don't want to have this conversation, do you?
What do you mean?
You're not supposed to be on banter here. There's no banter.
Banter. Do you know what banter means? I think there's certain situations where it's like you might want to lock that person up.
I'm not even disagreeing with that. What I'm saying is, for actual prison system, there should be a trained therapist.
Well, yeah, I think that the system itself is bad.
Right.
It doesn't do what it's supposed to do.
I don't think there should be a sentencing during the trial. I don't think there should be an actual sentencing. I think prisoners should have, there should be actual psychiatrists that's in the actual facility, and they have to meet with them maybe every year or whatever, and then they can say hey, this person has changed. We just start looking at an appeal trial. He has been actually rehabilitated. That may take people 5 years, 30 years, whatever, but there is somebody actually to honestly say this person has truly been rehabilitated. Let them go.
I understand that. I agree.
That's my logic. Not just saying, because some people can serve 30 years and still be just as fucked up as they were when they first got in there. So why does the time matter? It shouldn't. Is the system itself actually working? And the way it's designed right now is honestly flawed. Because if your idea behind it is, it's supposed to be rehabilitation, you're supposed to be making the person better for society or whatever. If you have life without parole, you do not believe that they can get better. And you have no evidence that person killed somebody. What are you holding them for? And then I hate that, that our system is set up for people that's never been in the system to begin with. That don't understand how cruel it can be, and don't even try to understand from a different perspective. You see what I mean? You have people that's from a higher class telling people from a lower class how they should be living and what they did was wrong, and you have no idea what they've been through. You see what I mean?
Oh yeah.
And then want to look back years later and say I was cruel. I could have told you that what you did was inhumane. Because people have a tendency to look at things black and white, and 9 times out of 10, life is not black and white.
Yeah. I mean, I don't know what you want me to disagree with. I mean, I agree with you.
Could always add it.
I don't even know what to add. You watched the whole like 20-minute video. I wonder where you went. They pretty much hit it on the note.
My dad would add.
Yeah, he knows more. Anyways,
I just,
let's continue.
like, to me, when I see shit like that, that makes me want to get into the criminal system.
Nah, no.
Why?
Stay focused on this. We going into medicine.
Technically, no.
No, you
I
can't.
could be.
All right.
I could be going up.
All right. Technically, yeah. Okay, you're right. It's theoretically possible, but let's focus on the doctor part first.
Why are you not running up so?
I know you sound very upset, but but we also have stuff to do.
Because I hate the world that we live in because it's so effed up.
And I agree with you. I do. But are you ready to go through this test so we
You
can
gotta give me a second. I still gotta run.
Oh, you are a big man.
Why aren't you?
I already knew this.
It's not that I don't know it.
Yeah, you knew it
But
already
sometimes
too.
you forget. Especially because we don't live in a lifestyle where we constantly see, like, the people that I see are in jail. No, you deserve to be there. Like, I know you were doing something that was against the law, and you served your sentence. Period. But to see, I mean, I know it's a fact that most people are, especially people that's on death row, are falsely incarcerated, but I just don't know why we're not getting together. Not trying to reform. Like, I want to be on that committee. How do I?
Brittany, no, because we really do need to get done with this.
I chose C.
Okay. You chose
C.
C. So why did you choose C?
Because density is mass over volume. They gave us volume, but it was in liters, so we had to change it to freaking
Yeah, you gotta change it to
meters squared. They told us 1 liter equals 1,000 meters squared, so that's
1,000 centimeters cubed.
That's 5,000 centimeters cubed. So in 1 centimeters cubed, there is 1 to 10 to the 6 centimeters. So you would divide 5,000 centimeters cubed divided by 1 times 10 to the negative 6, which gives you 5. Point. Blah, 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 blah. Blah, 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 blah.
Where's my
My math says. So yeah, I had to divide 5 times 3, 5 times 10 to the third divided by 1 times 10 to the 6, which gives you 5 times 10 to the negative third, and that is your volume. Then you have to, what am I looking for? Math. Multiply that? Yeah, multiply that times 10 to the 60. 10 to 60 kilograms per meter cubed, which gave you 5 points.
No, I was
Wait, hell would you change? I mean, I guess. What the hell would you do? Because they instead of changing it to, but that's a lot easier. They changed it to grams, centimeters cubed instead of.
Yeah. Third cm cube. I forget how I solved this. Just to make sure I remember how to do it. 10 to the third cm cubed times. Why am I getting this confused? CMV. Oh. Oh. We're trying to find the mass. You have to multiply the density by the volume.
Yeah.
Oh, what was I doing? Yeah, and then that just becomes like 5 times 10 to the 0. Which just... yeah, it just becomes 5. Alright, cool.
Right.
Next one.
Damn.
So, do you know? Huh? No, Brittany. So go through your reasoning.
Alright, so we're talking about the Doppler effect. Doppler effect is what?
No, I'm just groaning because I'm stretching, but continue.
Okay. So how I think about the Doppler effect is have a frequency of the actual sound, and then you have the perceived frequency. Yeah. So, and that has to do with the direction of how they, like, two objects are coming towards each other. And the idea behind it is the closer they get, the frequency increases. It appears to be louder. Further away.
It's a
So
higher frequency.
when I get-
You said louder. I'm saying it's not really loudness. It's
it does sound loud. It perceives to be loud.
that's not the point of it. It's not about magnitude of the intensity of the sound. It's about the frequency. It appears higher in pitch.
AK.
That's pitch and loudness are not the same thing.
In this situation, it doesn't matter.
In all situations, that's how it is. What do you mean?
Because remember, what you're doing is you're trying to pull into like the music aspect between no difference between pitch
No.
and yes.
No, that's
Okay.
this
okay.
is. I'm actually not.
Okay.
So like the whole, because you're talking about the Doppler equation, right? That's what they're talking about here.
Yes.
Because which is the F naught or whatever equals F and then times that fraction of V over V plus minus VD thing.
Yes.
So that frequency there is talking about like the actual frequency of it.
I said that.
Oh, I thought you said louder.
No, I said the frequency increases, so it sounds louder. Is what it said.
Okay.
So, it says the speed of the sound of an object and of the object moving. Okay, let's go back to the question. So the ultrasound examination can show the motion of a fetus. In order to image this motion, the ultrasound examination devices require what minimal information? So it says the speed of sound and of the moving object. So this doesn't talk about frequency at all, which is what's the most important aspect of Doppler's effect. So I said no to that one. So then it says B, and it says the speed of the sound, the frequency of the sound waves and the emitted. That was a good option. What else did it? Then the next one says the speed of sound and of the moving object. And the frequency of the emitted and the, and I guess the reason why this is wrong is
You're talking about B?
B.
Oh, C.
It's the moving object. You don't need the speed of the moving object at all. Because the idea behind it is you want the speed of the sound, because the speed of the sound changes the frequency increases or decreases. The object moving doesn't change the and then D is just wrong because it says the frequency and the wavelength is not equal.
Yeah. So do you have that equation memorized? You should probably memorize it. And when and in this situation, so like for me when I was going through it, I just kind of like drew the equation, right?
Mm-hmm.
And I said, well, of course we need the frequency, emit, and observe because those are the F parts
I
of it.
agree.
And then as far as like the V is like with no symbol on it, the regular V is the speed of the wave.
Waveform.
Yeah. And then VD and VS, that's like detector and source. So it's always kind of weird because like,
And that's what I was thinking
Yeah.
when I said moving object. Because it does matter the direction in which it's going.
it does. But one thing before we get to that I thought about was which one is the detector and then which one is the source? Is also a question to you.
The fetus would be the detector. The frequency. Object.
Yeah, the source is the ends up being the fetus, because that's technically what's and then the detector, like because there's VD in the upper part of the fraction. Oh, do you want to look at my screen? Oh, well then just look up the ultra that thing, not the ultrasound, but the Doppler effect equation. Because this is something you do need to memorize, because they do ask about this and how it works and stuff. All right, so yes, what we need is you can see the two F's. That's one is observed and one is actual frequency. We need the speed of the wave, which is just a regular V. We also need in this case, the speed of the source, which would be the fetus, and then VD is just technically 0 because the detector's not moving.
In a normal situation, it would be needed, but they're saying in this one specifically that the moving object is superfluous for image purposes. So I guess just for this is not important.
The speed of the object?
Yes.
Is the object is the source, right? I'm getting confused.
Okay, so this question is asking for the follow down which is what allows us to do image variable and variable stuff. Needed for imaging. There are 4 variables in Doppler, so the minimum required there will be 3 out of the 4 variables. We would. So the speed of the sound object. These are 2 variables and are too few and less than what we would need. The equation has 4 variables, 3 will be required. The sound and this answer choice would include 3 variables. False above would be the minimum information. What? I guess. That would be the frequency of the sound wave emitted and observed, and the speed of the sound. And that would be the same. If we were looking for the ultrasound examination, you could show the motion. Oh. See the idea.
Hold on. I don't understand why you get so upset.
Move my hip.
Oh, it's just weird. Because when I think about it, it's just not asking you to solve anything. It's just saying.
No.
Hold on. I just try to understand it for myself first. All right, go ahead and explain here.
I'm assuming you got
I'm still a little confused as to why C is wrong.
So first, you gotta talk about the question. The question itself is basically asking, what is the velocity of the source? So basically, with anything, you only like if you are in any algorithm, you only can be missing one out of multiple variables, right? So we know with the Doppler equation, there are a total of 4 variables. Variable 1 is the observed frequency. Variable 2 is the emitted frequency. Variable 3 is the velocity of the waveform. Okay, so technically I guess we should. And then you have the velocity of the object and the source.
Which is the object? The object isn't the source.
Correct.
That's what you're saying? I'm trying to figure out, is the object the source of the detector? Or the observer? In what Jack calls the observer. That's what I'm trying to figure out.
So the observer would be the detector. The source would be the fetus.
Right. And the fetus is the object?
No. The source. Stop saying you're switching words. You want to use source and detector.
But it says object in the answers. Is what's.
So object and source are the same thing. The object and source is your fetus.
Right. Okay.
And then your detector is the equivalent of an observer,
right,
which is the ultrasound.
Right.
So the actual ultrasound is not moving, so it can be negated.
Right.
So what they're saying is it's not even necessary to have. Okay. Right. Okay. Right. So we are looking for the movement of the object or source. So if that's the case, only thing we need is the velocity of the sound, the frequency that is emitted and observed. Because we're looking, the third one's the source of the velocity of the source and or object. So we're looking for the moving object. Because the observed is negated. Make sense? So you do.
All right, I get it.
Explain it back to me.
They're trying to find the motion of the fetus or the
Yes.
motion of the source.
Yes.
We just need the other
whole
ones.
purpose of an ultrasound is to find the actual baby.
Yeah, where they want us to find VS. So
Right. So that's why you shouldn't have any answer. How you gonna find something for me? Have that as a variable if you're looking for it.
understand it. Uh, I mean, I picked B, but it's hard for me to remember exactly what I was thinking.
You don't have your
You know, because I don't have my answers. Okay, next question. So, HF. Oh.
get the next one right.
I think.
Shouldn't you be there?
Oh.
Woo! Woo! Oh, are you taking that on?
What?
Number 28.
28? No.
Are you ready to move faster?
You got it right for the right reasons, right?
Oh,
I assumed that you
thought
did.
we were talking about all of them.
Yeah. Well, what is your reasoning then?
Bowling point, 3 points, always about overcoming in a molecular forces. So we hadn't found a one that's talking about animal forces. And so he's talking about hydrogen, which is animal. Boom bam.
So boom bam. Sorry, give me a hot minute.
I was not confident about this, but I made an educated guess. But I didn't like the way they worded this. On number 29.
Okay. I thought I made. I thought I made a thing on this. Electroplating. ABCDEG Kaplan. Chemistry. Atomic structure. Alright. Possibly be mentions and stuff. Alrighty, Rooney. Okay. So now we're on 29, right?
Mm-hmm.
So yeah, you got this one right. You know why, right?
Is that what we're doing now? I thought we were supposed to be.
No, let's go through it. Okay. Give me your thing.
So I was kind of iffy about it. But what I knew about quantum numbers is that it means how far it is away from you. So that's why I went with A, because I said radial size could say technically how far it is from the nucleus. When I started talking about shape, I was thinking that's more like.
There is one that tells you that, but it's not that. It's not the principal one.
Yeah, it's the S. I think.
Azimuthu, I think.
Yeah, I think it's the S one. And then you got valence electrons in the orbit. No. Yeah. And then it's the number of protons and neutrons in the nucleus. That's your atomic number. That will tell you that. So, atomic mass. Atomic mass will tell you that. So, yeah, that's what I went with that one.
On to the next one. Metal ions present in plasma are expected to
Chart, table 2.
on the right of table 2, right? The last column on table 2.
Hold on.
Oh.
Because the last one on column 2 just says out the.
So that one gives you the
Binding concept out.
so when yeah, where it says note above it, where it says binding constant of it in the absence of, That's what KO means.
I agree.
So, and then, do they say what the KA means?
It is always the dissociation constant. What do you mean?
Sometimes it can mean something different, I think. Because basically the way that I was interpreting it, that last column where it has KA divided by KO, that's basically telling you like, normally it's 1, but then with it present, it's decreasing it because it's less than 1 now. It's making a comparison between the two. Sorry.
That's what you do to me all the time. That's not what I. So dissociation constant means that the compound's going to break apart, right? So I'm comparing it as the KO, like that value on the far right side is basically telling you when magnesium is not, like a metal ion is not bound to it, the dissociation constant. If once you add the magnesium, like metal ion, that's when the dissociation constant, then it increased the dissociation constant. That's what I'm saying. It is. So if it disassociates more when the metal ion is present, it would decrease the amount of blah 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 bound to BSA. It will be breaking apart. Make sense?
Yeah, hold on. Trying to find out where it. So the Ka in this case is talking about the binding constant. It's not talking about acid dissociation. That's why I was saying like, so like, yeah, there's sometimes like, normally when you see Ka, that's talking about Ka. But in this case, the Ka is talking about binding constant. And
Where'd you see the photograph?
I inferred that because of what K0 was. Yeah. So, a couple things. And in the paragraph above table 1, it says that that's what they were looking for. Where it says like the binding constant of CPU was determined using blah blah blah. In addition, whatever. So that's, and then it says BS for table 1's like description, presence of warfarin and ibuprofen, and then it says note KO represents affinity constant. So like, yeah, that's kind of how I came to that conclusion. that one was oh, so if you look at like the note, right? And I keep referring back to this note. It says that the binding constant is in the absence of the metal ion, right? And they set it up as a as essentially as a fraction. So we know what the bottom of the fraction is. That's how it would bind if it was normal, right? So if we're making a comparison between that and something else, what must the top probably be then? The binding constant when a metal is present. Yeah, that's essentially what it is. But the point is that in that sense, the Ka must be the binding constant. It doesn't yeah.
What's that to do with the whole one being?
Because if it was, so if, let's say for example, the K0 was like 3, right? If my K, if that's how it is when I'm normally, like I'm at 3, if I decrease lower than that, like, which is what's happening when we add the ions, it's decreasing it, it would end up being a fraction, right? And it would be some number less, because 3 over 3 would be 1. That'd be, it's the same, there's no difference. But if my top is less, then it's going to be like 0.99, 0.87. See what I'm saying? So in all those cases, it's always yeah, it's always less than 1, so all of them are decreasing the binding. Yeah. Oh no, I'm not. I don't know. What? I don't know. Whose couch is that? All right. You don't? You don't?
Beautiful. Oh, I guess I got the next one.
Nah, I've just been going on.
Oh!
But let's continue.
31. What natural color biochem food makes fine to the same as heavy growth? What was my? I wasn't, 100% like, ooh, I know this. I was real like, ooh, what am I supposed to do? But this was my logic. Glucose got a whole bunch of like OHs in it. And this one got enough OHs. So it don't even look like that. Right? So it can't bind to the same site. That's have roughly the same structure. ATP got all the phosphates. And this ibuprofen don't got no phosphate. That's it. Can't be that easy, right? And then glycerol. Glycerol, I don't know what that look like. But with pigmented acid, I thought that has some chain, right? And then it has a carboxyl group with the acetic acid. I think that's still cool. That's why I love it.
All right, moving on.
Oh, you gonna accept that answer?
Yep.
Why?
It's right enough. Based on the data in table 1, the binding sites of CPX and BSA were determined. The binding site of CPSX on BSA was determined to be yeah.
Alright, let's see. Based on the binding site was determined to be table 1.
Yep.
If you say yup one more goddamn time,
You need to stop cussing.
or what, Renee? What? Whatever I want to say.
Tell your mom.
Go right ahead. She knows I cuss. She don't approve of it, but I do what I want now out.
All right, let's continue this.
I'm still reading.
Oh.
I'm reading. misinterpret it having a big. Well, I mean, are you? I guess would you encourage?
Well, so it makes sense to you as to why that's the answer, right? Now that you understand what the table's telling you. I'll leave it up to you whether you want to or not. I personally do. Just the reason why is because, not necessarily because it's like the information is useful, but because reading graphs and tables is a skill that you can develop by simply just looking at them over and over again, you know. Granted, you can get that by doing a test too. So I don't know. So whatever you want to do. Huh? I would just repeat the question. Based upon, yeah, I'll just repeat the question. Or ask, what does, yeah, I would say explain why that may, yeah, actually, yeah, explain why that is the answer, is what I would do.
So my reasoning is
So which one are we on? No, I went backwards. I was looking at something. So 6, 1 and 2. 33.
I'm talking
34.
All right. Where's my math? Math.
Yeah, you just needed the mass from the paragraph. 35. What?
Alright, it says, what is the relationship between TNR? In the graph, you see temperatures increasing in the same way. The resistances, so they have a positive relationship.
And
Positive,
yeah, because R goes up in the same amounts pretty much. Yeah.
Luke got that every match. This is about specific heat. So using the MCAT equation, so you will have to find the difference. That increase by 200 degrees. That's your T, delta T. And they gave you your specific heat, which is 460. Your mass, they would. Yeah, so this mass is 4 times. And when you do all the math, then you get 368.
Yeah.
Back to darn circuit. chart too.
Yeah, you can. I didn't know. I got pretty sure I got this one wrong. Are you looking at my screen? Oh. Why are you smacking?
You do it all the time. No, you breathe heavy. I'm not sure. You breathe heavy.
Well,
I get to see the finish. You added something different. Don't do that. Wait. Oh, stop. I got that wrong too. Lost my roll.
what are you doing?
Anyway,
So, literally all I added was I just repeated the question.
It's okay.
I literally just
It's
repeated
okay.
the question.
just it's okay. What's that? That's it. I need. Okay.
Can we move on?
No, you already.
And they're live.
Selected for C14 plate will be back on.
New.
Neither one of these gave a good explanation.
No, they're just gonna say this is what happens.
Yeah.
Huh?
You know what to next.
I would like to, because at least if I can figure out a good way to solve things like these easier. Well, I was just saying, okay. 14 reserved and is next to the carbon monoxide. Well, I'll keep this in mind later. I'm going to figure it out, but not right now. So I think you just have to know that that adds there. Is that how you?
Whatever, there you go.
Okay, 1, 2, 3. I figured it out. You can't. That's not a bad thing to do, is that? Because it'll teach you the mechanism. But so literally, what you do is you, on this one, they literally just label the carbons, and you just keep that labeling. So like, you know that this one is carbon 1, right? This is the first carbon, 2, 3, 4. And then do the same thing over here. So like this has to be carbon 1, this must be 2, this must be 3. And then 5 and 4 must be bonded to 3. You know what I'm saying? So then we go back here and you just keep 1, 2, that one's 2, and then 3, and then these ones right here. Same thing over here, you know that this has to be carbon 1 with the carbonyl on it. You just go back. So you know that, okay, if I keep going backwards, I'll be mentioning it. So that means that this has to be 3. You know what I'm saying? So yeah, that's all that person did. I mean, yeah, but I just wanted to make sure that there wasn't like any sort of like deeper lore to it. Because the reaction mechanisms are not heavily tested ever, which is why I thought it was weird that they wanted you to know. But you can go through it and figure it out, the mechanism behind it. But I'm like, that's really detailed. You wouldn't be able to do that on a test. So like, there must be like a fast, quick, and dirty way to do it. And that's the fast, quick, dirty way. So did you want to make a note on that, or are you just gonna go to the next question? Malevolent exists in equilibrium with compound X in aqueous solution. What is the structure of compound X? What is malevolent? Oh, okay. Which one is compound X? So how did you think about it? Huh? So what I kind of came to my mind was, okay, granted, I feel like I had to look at the answers to kind of see which ones made sense. But basically they're saying that when it's by itself, it does some sort of equilibrium change where it's either cyclizing or changing the way it looks back and forth, right? So clearly it seemed to me like, I was like, okay, so they're getting at some sort of cyclization going on. And I was basically looking at, okay, which cyclization makes logical sense? So I started ruling them out, is what I did. D is completely insane to me because it just looks weird, right? And it's basically saying that CH methyl group just gets removed. So it's like, where did it go? That's a completely different molecule, a completely different formula. Well, oh no, you're right. Oh no, I don't know that. I thought they were.
Still one less of an oxygen.
Oh, that's what it was. I knew there was something where it was like they got rid of something, so that can't be it. C. I mean, I don't know if I got this one right, but A does make the most sense to me. I should probably look up and see what the people say. And by people, I mean Jack. People, I mean Jack.
You just need your brain. So the oxygen. It's negatively charged oxygen.
Yeah. That one has 4. And I think it's because it has to lose an oxygen.
When?
Because it has to lose a water. Because that's what happens is like that carboxylic acid oxygen attacks that one. I mean, you see the thing. It loses a water molecule. That's what. And I think this is one of those things where it's like, because don't get me wrong, there's a lot of ways that shit can go weird and sideways in organic reactions. I think it's just there's certain ones. This is one of those ones you just have to know that this can form a ring. So when you see like, oh, there's this group and that group, it can probably form a ring, and if it does, it would look like this. Yep. Snap. Hmm? Hmm. Uh, refund the world. Refund it sooner. Right as a consumer. Yes. Yeah. All right.
Oh.
What?
That's not right. That's not true. It will have a peak between the 32 and 35 area. And those are for CH bonds. I call bullshit.
Ooh.
You?
What are you talking about, Bernie?
Question 40.
Yeah, I know. You're saying it will have a peak between 1580 and 1610?
I was talking about that.
Yeah, it will have one at 3200.
Yeah.
That's what it's saying.
Oh.
Jeez.
That's what I was about to do. Yeah.
Just crazy. What do he want, bro?
You want answer?
I'm trying to, Brittany. My phone don't work. Hello? Hey, what's up? No. Studying. What's up? Well, yeah, I don't really know. Maybe next weekend. Yeah. Yeah. Well, how about Sunday? Oh, yeah, that's right. Yeah, okay. Yeah, I'll do Sunday. Alright. Hey, mama. Alright. Always have. Okay. So,
What are we doing?
they just wanted Super Bowl Sunday.
Mm-hmm.
They wanted me to come see him, so my dad can talk about something that his new. Yeah.
Let's get it.
10. That's the one I'm looking for. Reposition to that. I'm just asking. I just have the IR stuff in here.
And you have a memory?
Hmm?
You have a memory?
No, I haven't. I think I got this wrong because I just didn't know him.
Yeah, I knew the CH.
But that's all. You just gotta. That's all this one's asking you. Do you know your stuff? Yeah. All right. So you gonna make a card on this stuff?
Clearly.
Also, what are you gonna do about food? Nah, that's not gonna help me too much. Brittany, what are we gonna eat?
We eat leftovers.
That what we eating?
You got something else in mind?
No. I mean, we go for some chili.
Nah. I'm putting my foot down this time. Hell to the no.
Why not?
Because we eat chili every other day and I can't.
We really do. We really do. God damn it, Brittany.
Shut up. It's different what I say.
Damn it.
Alright. Remember, no government names.
Who knew, bro? Anyways, continue. I went to the next question and I was like, because I thought there's no way enzymes are chiral. They are, apparently. Yeah, I was like, what? It's like, dude, don't be silly, AMC. Enzymes aren't chiral, they're enzymes.
Fucking bro.
Enzyme is a chiral catalyst. Who knew?
How am I supposed to know the medium was achiral? What?
Alright, focus on you.
Where will the absorbance peak down? You know. What does your card say while you jumping around?
For what?
Your IR spectrum.
I already had some made, so I just pushed them up to the top of my deck.
You're like, ooh, if I open that, he did that. I mean, she's so fine. Give me, it's over there and flow. Give me my pen.
For
IR space, except that's a car, so. Alright. That's what I was talking about.
no, I wouldn't. No, I wouldn't.
You know, people hate this a lot.
Nope, they can't
Why?
because I have a sound filter on.
Right, it's loud enough.
No, you can't.
Maybe I can hear you from all over the mic is.
And I made the mic so that if I chew away from it like this,
Yeah.
nothing comes up. I can see it. I'm looking at it right now. There's no volume input. There's no reading. So you're wrong.
You gonna show me, bro?
Yeah, I have it pulled up right now. You had Brittany, you don't need to take a picture of this. It's literally that.
I can't see that. I'm sure. I didn't take a photo. Stop! That's not. You wouldn't do any stuff. I should have that was. Well, you know.
I have several cars like that. So like I have one for that, one for this one. See?
Oh, that wouldn't be my deck. Let's do a random thing.
No, they're not all important.
Like, I think you can kind of cheese, and the aromatic, carbon big branch. Yeah, carbonell's is around 1700 or around somewhere in there.
That I'm like that.
Did you go for alkenes and alkanes?
Technically, yeah, but you know, yeah, I did. Is that the compression? Maybe so.
No.
Whoops. This could be a death rush where you actually be very, why am I don't know. We're very used to mid-reaction. One of the reactants, either one of the reactants. Both the reactants are chiral. Hey, what? Chiral. At first glance, this answer choice sounds good. Chiral solvent will promote a chiral reaction. However, keeping in mind the content of the reaction as an in vivo reaction inside of a living organism, this answer choice holds less weight. Maybe answer D should provide more forensic methods. I'm sorry, did they make any sense? Basically, you could just, all the other ones are wrong, so this has to be the answer. There's more. I looked at. There's also a solution manual from Next Step, I think. No, from Princeton Review, that has the sample test in it, and it literally is like the same thing, in different words. But it's like, yeah, you can rule out the other ones. They have to be wrong. Yeah.
And it just says you can't just chiral solvent in a human. Is that what you're saying?
So hold on, because I want to say, did they say anything about the solvent? In vivo means in the body, right?
Yes. Yes, inside of living organism.
So yeah, in the human body, because yes, a chiral, yeah, like he was saying, if he had like a chiral solvent, then maybe that could be it. But we're in a human body, which is like mainly water. So yeah, it doesn't hold weight to have a chiral solvent. And since you eliminate all of the other ones that can't be right, it leaves you with the enzymes being chiral. Which, when you think about it, kind of makes sense because he explains, like, you know, our amino acids are chiral. Most of our sugars have a certain chirality that we stick to, right? So it makes sense that they would use only one enantiomer, so that means the enzymes are probably chiral. Like they don't do anything with the D stuff. So I literally just said I did, but it was literally like just enzymes can be chiral. Enzymes are technically chiral. Like, okay, cool. Like, because it wasn't. That's literally all. This question was literally just a process of elimination question.
I can remember that.
Yeah.
Now I know. I learned a lesson. You know, babies probably love Kiki.
Babies?
Yeah. You think about it. You know, a baby comes sit up on me. I ain't nothing but skin and bone. That's all. TJ just up there, plopped up there, just as happy, like it was laying on the bed.
All right, let's continue.
Says which substance is not a product of squalene? Squalene is and cholesterol synthesis, so we'll be predicting that gelatin is not a derivative of cholesterol. Testosterone is a steroid hormone, aka a derivative of cholesterol. Cholesterol is cholesterol, so cholesterol, yeah. And then cortisone is a steroid hormone derived from cholesterol. Glucose is a sugar, not derived from cholesterol, so I chose A.
Yep. Next.
Alright, so it's myopia. Myopia is a condition of the eye where crystalline light lens focuses the light rays to a position between the lens and the retina. To correct this condition, a thin lens is placed in front of the eye that would help focus the light on the retina. This type of lens requires a diverging lens. So cylindrical, that's never even an option. So you will use a converging lens for hyperopia. So myopia just basically means that you are nearsighted. You can't see things far away. The reason is because you produce an image in front of your retina. So a diverging lens will spread out that light so then it can reach back into your retina. That's why.
Cool.
Ooh. Wasn't too sure about this one. One method of isolating polypeptides and proteins from an aqueous extracting is freeze drying. The aqueous solution of the polypeptide or protein is frozen. What procedure can be used to remove the water from the frozen sample? Again, kind of guess, but I presumed they wanted to keep it frozen. Okay. The distillation using steam, you're gonna unfreeze it, so that steam, right? And then extraction during the solvent, again, you will still have to unfreeze it in order to extract it. Addition of magnesium sulfate you'll be dissolving it. Didn't seem right. So sublimation, I know something was. I don't know the actual definition. Sublimation. But yeah.
Sublimation is when you go from
A gas to a.
no, I think it's
Solid?
a solid straight to a gas. Wait,
It's solid into a gas. Yes. But without.
it's sublimation. Yeah, you skip the water part.
This would be so because no melting mechanic will be involved, and the proteins would stay under their current frozen formation. It will also be susceptible. Yes.
What do you mean? What am I doing?
You know,
You said what?
all of my questions. Once we get to
Okay. Me too. So what? So you ready?
What?
The next question. So where are you at? Like thought wise? Two glucoses. You're looking for something that has two glucoses. Makes sense?
A cyanide.
Yep.
And a benzoyl aldehyde, right? So, first one, do I see all that? Yes, but the benzoyl aldehyde, this is my thought. Benzoyl aldehyde, like to me, I thought they should all be on their own, like little different. So, I do see two glucoses. I see the cyanide and I see the benzoyl aldehyde. That's awful. And then for B, I see the benzoyl aldehyde, which is dead in the middle. Cyanide and the two glucoses.
So the point here is that when you add an acid to something, it protonates crap, right? That's what it does. So when you protonate those two like sugars in A, you get those two sugars separate, and then also the benzaldehyde piece that separates because you're adding hydrogens there. You're essentially adding water into it, right? If you do that to compound B, that cyanide stays connected, and you just get one with sugar with the cyanide on it, and then one sugar with this weird, crazy looking group on it. It doesn't give you what you want. That's why B is wrong. because yeah, when I was looking at this, I was looking for oxygens to essentially be like hydrolyzed, essentially, by the acid. And yeah, and I was also looking for 2 equivalents of sugars, a ring someplace, a cyanide someplace, and yeah, in places that make sense to where they could separate off and stuff. All right. Oh. Yeah, so are you ready? Huh? Yeah. All right. Is that how you do this? Is that how you do it? Hey, wait, hair must wait, hair must. Okay, I got it. So, um, got something else in it. Oh, he left it there. Okay. F cavity. I already clicked it. Didn't help me, so. And Maybe I do. Hold on. Force of the weight of the. Alright, I think I get it too. Some of these Jack West explanations are just as bad, but not all that great. So the weight of the object and the buoyant force. Right. So if you say like, if you basically, this guy over here set it up as like a proportion. So, which is something you can do with some equations. So, if you look at this, this is like the weight in air, right? And this is the weight in the what?
You talk.
And this is the buoyancy force, right? So you put it as a fraction, which means you put these as a fraction. The volume of the object and the volume of the fluid displaced from the buoyancy equation are the same. So you can cancel those out, right? Because the volume of the object, if it said in a question sentence that it was completely submerged, so the volume that gets displaced is going to be equal to the volume of the human in water. Submerged in water, yeah. So they're the same. These V's are the same, so you can get rid of it. G is going to be the same, so you can get rid of it. So you end up with this, right? Now, FB, or the buoyancy force, is going to be equal to the weight in air minus the weight in water. It's going to be the difference between those.
How much you weigh, yes.
Yeah. So you can literally plug this expression into FB, right? And then this is the weight in air, essentially, right? And that's how you get that. And then the density of the fluid, which in this case is just water, is just 1. Water has a density of 1. So when you do that, you get the density of the object the human is equal to. No. Why are you always copying me? Somebody. No. Draw this differently. Boinky. Kaboink. Plow. Kerplow. All right. Hello.
Comment. Connect this, bro. Let's go up. I got a question too, bro.
What do you mean heave?
It's heave. H-E-V.
That doesn't exist anywhere.
Yes, you do.
Here, so R.
That exists. It exists. Why'd you put here?
Because in this situation, the volume VF and VO are equal to each other.
Because it's a merge.
Yes. Okay. All right.
So it basically wanted to know what was the net charge of both of those cellulose go up to pantothenate. So I always look for the carbonyl and the nitrogens right beside each other. That's a function number. Like that's the start.
Mm-hmm.
So then when I look to the right, I see the carboxylic acid, and so that means it has to be glutamate or aspartate. So either way, I say -1, and then I look to the other side. I don't see another NH or carboxylic acid. I don't think there's any other amino acids on the opposite side. So that's why I said that pantothenate. So then for the phosphorpanoate, again, I did the same thing. I saw the carboxylic acid. I saw -1, and that's why I said they were both -1. No, I guess what they wanted me to take into consideration is also the phosphate group.
Yeah, because I made the same thing. I was like, oh, so it's just -1, but it's not.
It's not.
The phosphates deprotonate too.
So
I mean, no, yeah, the phosphate does, not phosphate.
that would be an additional -2 because phosphate is negative. But it deprotonates. So yeah, you go.
Yeah, just because the point is to know that deprotonate. I didn't know that. That's all I did. What are you gonna eat? So do you want to go get something? Okay, then let's just go get something.
You keep saying it's not the problem. It's not if we're going to eat, where we're going to go get it. It's what we're going to eat, honey bun.
Let's just go to when dies.
You sure? I know how you got beef.
Nah, it's cool. Let's just roll over there. Yeah. Where's my...
Yo. So what?
Huh?
So what?
What are you talking about? Yeah. That ain't. I mean, people come in and out. The most? One.
Today?
Yeah. Someone's here now.
Hey, y'all. Yes, it does.
Yeah, it does.
How rude it
Yeah, fuck that.
is.
My little binder pad. Yeah. I don't know where it went.
Still on the couch. My white.
Thanks, bro.
Don't touch me.
Oh, please, God.
Come on now.
I'm so engaged.
The question says which components comprise the potent enzyme A? Figure 1. So looking at figure 1, potent enzyme A. So again, didn't know what half this shit was, but I did see something with 2-phosphate. So anything that had like a AMP, I said no, because it's ADP up in there, right?
Yeah.
And then figure out where the ADP was, like I knew it was on the and then basically it was trying to figure out where that additional phosphate was, and I already one. And then as far as everything else was concerned, it really didn't matter because as long as you can do process of elimination, I can eliminate PSC and then release A, just based on the whole ADP thing.
Right.
The hell I did. So yeah, moving on to the next one.
Nice job.
Appreciate it.
All right. Give it to me.
Pantothenate and Pant3 is most likely stabilized due to the inactive site.
I'm an idiot. Okay, but anyways, can go ahead.
But yeah, it should have been smart thing.
Yeah.
Smart thing. Just,
You know what? That would have been really fucked up. It's different. All right. So let's continue.
Amino acids, aspartate, and arsine. Histamine and arsine are found in the ADP family straight up. Blah, blah, blah. Which should be actually two position of ADP binding described in the passage. Oh, it says it involves a predominantly ionic interaction, so it's going to have to be something that is charged. So you got asparagine, threonine. You got asparagine and threonine. They're both uncharged. And then for B, you got histidine, which is positively charged. You got arginine, which is positively charged. For C, you got aspartate. It is negatively charged.
Yeah.
And then arginine is positively charged. Yeah. And then for D, you got aspartate and histidine. So really, B, C, and D are all charged, but I just want to have two basic groups, not enough basic enough.
Yeah. All right, but I mean, I just chose it because I need something to attract my negatively charged ADP.
Yeah.
That's how I thought about it. And I said, well, I need something positive in there. And yeah, also the stuff in the passage said that too. So yeah.
So with here, I wasn't quite sure, but I do know that you got rid of B and C because NADH is always oxidized and NAD is always reduced. So I got rid of those. In my experience, half the time, NADH is getting reduced, so that's why I chose B. I did originally have A. It says in paragraph, the pyruvate is converted to lactate by lactate dehydrogenase with simultaneously use of NADH. So if it's a dehydrogenase reaction and you have NADH, dehydrogenase means you're going to remove hydrogen, remove water. So if that's the case, you're gonna Need to take out my.
Hmm.
I guess. Yeah, I guess. Yeah, I guess. I was kind of straightforward. It just says NADH is used, not NADH plus.
What is the phase of NADH used in the described above? NADH. Pyruvate.
The dehydrogenase is protein. I got the answer.
Pyruvate. Okay, I was confused.
Yeah. And that in the paragraph it explicitly says that NADH is used, not produced. So if it's used, one thing it can do is be itself oxidized.
I'm pretty sure. I think I got this one right. Because my thinking was like, oh, they're just talking about fermentation
Right?
and production of lactate. So,
Right.
yeah, NADH just gets used in terms of NAD plus. That's it, and it gets oxidized. But what's weird is, so they're saying NADH reduces lactate to pyruvate.
I'm sorry.
See, they're saying NADH on the AMC. But I'm just saying, like, just in general.
NADH reduces lactate.
Is that actually what happened? That's what I'm like, that's weird.
I think they're saying lactate gets reduced, not the NADH is getting reduced. Means that it is oxidized to NADH.
So the way that I think about it is this: NADH reduces pyruvate to lactate.
Yes, because it is a reducing agent.
Right.
Right?
Which is why they say it gets oxidized, right?
Yes.
So that's right. I'm just saying that it's just weird. Is in the solution thing where it says A, it says NADH reduces lactate,
Right?
which is not right.
Yes.
NADH reduces pyruvate.
Come again?
NADH reduces pyruvate. See what I'm saying? So what are they talking about? Yeah, and even in Jack Weston says this is correct. NADH donates its electrons to pyruvate, which means it reduces pyruvate. It gives electrons. It gets. All right, we're moving on. I just think that that's wrong. I think that is a legitimate mistake. Everybody makes mistakes, I guess. All right, next one. What?
The most I can say is what is the fate of NADH and lactate formation. I can do that.
This is the yeah, this is the I got this one wrong too. It's just E equals HF, but then in the question stem you had to convert the 140 kilo electric volts or whatever. You had to convert that to joules, and it gave you had that conversion in the question. And then from there you just do E equals HF to find the mixing variable. Know what I mean?
Nope.
It's a plug and chug. So they give you the charge of E equals 1.6 times 10 to the negative 19. Yeah. No.
Kelvin.
That's not Kelvin.
Where is that in the question step?
What are you talking about? What, the 140? No, it's not in the question stem, it's in the paragraph. The one in the
I
last.
see the 140, but how does that mean that KEV times coulombs gives you joules?
Hmm. There are 1.6 times 10 to the negative 19 joules per EV. So that's something. Negative. So yeah, you can just know that 1 electron volt. So like,
Is that the AKQ?
y-
Oh, you talking about the
yeah, so like literally what electron volt is you take the elementary charge, which is that.
what's it? BEV?
Yeah, keV is just kilo electron volts. So if you remove the kilo, it's just electron volts. But literally what it is it's electron volts are literally electrons times voltage. or an electron times the voltage. And when you do E times V, it ends up being joules. So like the E 1.6 times 10 to negative 19th C, that's coulombs. If you multiply that by voltage, you'll get energy. And the voltage is just voltage. Like there isn't an actual number for it. Like it just comes out to be joules. Yeah.
Electron voltage. That's the E and the V, and the K is the kilo, and that's what.
Yeah.
Yeah, same question.
The electron volt. Bones. You don't say it right.
You don't.
All right. You're not done yet? Oh. My bad.
What was your bad, bro?
What?
I'm not putting that on. That's not whatever tomorrow. I try to look specifically the little line of shit of happening.
Okay.
The electric. you got beta emission, beta capture, so electron capture.
Positron emission
Yeah, positron emission.
And-
Positron emission releases a
positron.
right, and then with electron capture, that captures. It takes a electron and changes it to a neutron. Versus
An electron.
emission takes a neutron and changes it to a
Proton.
electron.
No. In positron emission, yeah, we lose a neutron. Does a neutron? I'm actually now I'm confused. Okay, in positron emission, a proton is converted to a neutron because it shoots out a positive charge. In electron capture, an electron gets captured by a proton and it becomes a neutron.
I literally just said that. No, I know. You heard me. You just didn't know, so you denied it. In electron capture, a electron gets changed to a neutron. Hence why it decreases by 1.
An electron doesn't get changed.
Yes, it does.
A proton captures an electron.
And changed it to a neutron.
Yeah, and it becomes a neutron. If anything's
What?
you have your understanding, I have mine.
It's going from an electron to a neutron.
Okay.
Whatever, nigga. What you doing over there, Ryan? Got tapping keys so freaking hard.
I just like to type. I'm not doing anything.
If I get up and I'm gonna look at your screen, it's gonna look like you ain't doing anything.
Yes. What?
So the advantage of the Doppler ultrasound technique over standards is that it allows. I don't even know what the standard is. I don't remember the conversation. Talk about standard versus Doppler. I guess my thought process was, I know the Doppler effect that you have to have velocity of the waveform, you have to have velocity of the object. Source velocity of the observer, and then you have a overall frequency, right? So I think with blood flow, if you have a velocity of the source, so that's why I thought it could measure blood flow. But when you say distinguishing between fluids and tissues, what? I've never seen an ultrasound be able to do that. Because it's not, Doppler would never be able to distinguish between two. It's just about frequency itself. Makes sense? Okay, so my answer for B is right. The fact that you will have something.
Yeah, the Doppler tells you most, can tell you frequency of stuff, how that changes, and then it can tell you the velocity or how things move.
Right.
Right. That's what it tells you. It has nothing to do with density, nothing to do with wall thickness or anything like that.
Right.
Yeah. What?
What are you typing? Yeah, I saw that 30 watts. That's which is again normal work. So I should have converted it to seconds. Okay, let's backtrack. So work is force times distance, or the change in potential energy in the vertical direction, but if you have watts, that is power over time. Right. So if you were to just multiply that times the time itself, that would give you work. So you should have converted that 3 minutes into a second.
Yeah.
And that would be.
Gonna drill you. And now you bleeding.
When choosing a buffer to use to experiment with special seeds, so the point of a buffer system is to you want to this changes. So typically what consists of a good buffer solution is a salt with this conjugate acid and or base. Weak conjugate acid. So that means in this situation we're looking for something that's either a weak acid or a base. So 2 is gonna be like a stronger acid. You want to peak, and the other thing was you want one that has something similar to the pH, so it won't differ. So since we're more on the acidic side, that's why I chose one that's more acidic than.
You just want to pick the pKa that is within plus or minus 1 of the stable pH. That's it. All right. That's literally it. Just if you want it to be, the buffer system works within the 1 plus or minus 1 of the pKa. That's it. Yeah.
Oh.
How did you get this one? Wow.
Oh, I had like 3 minutes on.
Oh. This is the Q equal MCAT again. You're just rearranging it in a different way.
Yeah.
And then yeah. And then the last one is if you can balance equations. I got that one wrong too. I picked A, the first one also. I'm hungry. I want to eat. Then I'm gonna do my cars and do 2 cars pets.
So you gonna cheat the system and not actually work these out? Why give up now, Raymond? We done spent 5 hours. There's no need to actually give up now. Sit on back down. Sit on.
I already know what's going on. I'm trying to help you.
No, you're trying to eat. You literally was about to walk out 2 seconds ago.
Bro, come on.
I'm not.
Okay, start thinking then.
I mean, I guess because there's only supposed to be 1.
How did you know that?
I've never heard them talk about 2. 2 is
I've always heard them talk about 2.
2 is produced. 2 electrons are given. That's what
Type in lactate fermentation on Google.
it
Type it
gives.
in there. But that's stupid long to get a picture. There. Wow, stop. Fermentation, yeah.
Fermentation.
Now, see? What images? Two NADs. Two NADs. I have no fucking clue! No, so the reason why is because the real reaction is actually this. You only need one, and then there's a hydrogen, which I have no idea. But the big thing is, yeah, making sure that there's a same
But
number of atoms on the side.
But that makes sense here.
Yeah. What if you have one?
What?
What if you only want one pyruvate there? What is it? You only need. See what I'm saying?
Is that what it's saying?
Yeah, it's a single pyruvate that you're making. Now the one in the body creates two.
Right.
But if you're just getting one, then technically it's all the stuff in this reaction will get double.
Right.
Which is where you get the 2 NAD.
Right.
But if you just decrease it all, it's just this. So I just made a note of like, oh, the actual reaction. Like, you can look it up. It actually like is just that. And then the other thing that you want to keep in mind is make sure the charges are balanced. When you look at balancing equations. The charges have to be balanced.
Not first.
The first one, this is -1, and this one is +1. One, they have to be neutral. It has to be neutral.
Oh, plus one. Minus one plus one minus one.
Well, they have to be neutral.
What do you mean?
Neutral means it's 0.
It is 0. You have a -1 and a +1 overall.
This is 2 plus 1s. Because there's 2 hydrogens there. All right. I'm getting off this thing because I'm hungry. Bye.